So please confirm if you all of you can see my slide, tollgate checklist. Whatever we have learned, we are going to know. Just verify ourselves.
Yes.
Yeah. So quality is meeting customer requirements consistently. Is that true?
True.
True.
Quality occurs as a result of 4 activities. Do you remember the 4 activities which we learned? What is the first activity? I'll help you with the first activity. Understanding customer requirement. That's the first activity. What is the second activity? Designing your product or designing your service. What is the third activity?
Develop a process.
Beautiful.
To meet the
Process
customer.
development. Process development. And make sure you include the word capable. Develop a capable process. When I say capable, it can produce output in line with your requirement. Right? But now, even after developing, a capable process, the challenge could be the performance of the process in a long term. Why performance of the process in a long term becomes a challenge? Variation.
Variation. Yes.
The incoming material variation. All the input can have variation. Process conditions can have variation. As a result, you will see the same variation in the output. If the variations are minimal, customer cannot notice it. The variations are more, customer can start rejecting your product. All of you agree with me?
Yes.
So it is fundamentally the variation that is bringing the trouble. Whether the variation is happening on the right side, which is your X inputs, or the variation is happening on the left side, which is your output. If the variation is on the output, customer could see it. Right? But the challenge here in any business is, can you see the variation even before customer can see it? Can you be proactive?
Yes, sir.
Much better idea is, can you look at the variation on the inputs instead of looking at the variation on the output? You are much more matured now. Am I correct? So
Yeah.
this is how we become slowly, proactive. Otherwise, you will be staying reactive. So the last step is process control and process improvement. This is what we have been talking, right from day one. Y equal to f of x. Now can we, safeguard our y? Y can be y1, y2, y3, y4, y5, etc., etc., etc. Because customer requirements are many from any product, any service. So there will be several y's. You need to safeguard all the y's so that you can proudly say your product is best in class. Am I right? Your product is best in class. When can you say your product is world class or a premium product? Can somebody answer this question? When can you say your product is world class or a
Yes.
premium?
When we meet the customer is satisfied with our product.
Okay.
Good morning, sir.
Voice of
Good morning.
customer.
Yes, sir.
One by one. Yes,
when-
Akansha, you want to say something? Yeah.
Yes, sir. When everyone is ready to take that product, so
Oh,
that
well.
means it is
Very
acceptable
good.
in every area.
Very good. Very good. That's correct. Yes, Sandeep.
Voice of customer. By getting voice of customer.
Yeah. In fact, all your answers are like voice of customer only. There is a difference between voice of the customer and your, the technical language. Am I right? You can't expect your customer to speak in a technical language. Similarly, can you use some Six Sigma terminology to define a world-class product?
Defect-free products.
Yes, defect-free. Much better word.
If a process Six Sigma controlled, then it's world-class for.
Incremental improvement, sir.
The variations are minimal in your output. Whatever you committed, customer will see exactly the same in the product. If at all there are any variation, the variation will be very, very minimum. Let's say you are sitting in an air-conditioned room. The air conditioner says room temperature is 24. Does it mean the room temperature is exactly 24? 24 plus or minus. Imagine you have an air conditioner which gives, a display of 24 plus or minus 6 degrees Celsius. What does it mean? 24 plus or minus 6? The room temperature can be, it can show any value between 18 and 32 degrees Celsius. Is this product a world-class product? Is this a premium product? Room temperature is 24 degrees Celsius, but air conditioner is showing as 30 degrees Celsius. Can you see more variation here? Yes, sir.
Yes, sir. So it is not appropriate, sir.
Yeah.
It should fall within the bell curve.
Yeah, imagine another scenario where an air conditioner is working with a very low tolerance, 24 plus or minus 0.5. Now the room temperature of 24 degrees Celsius will be shown as any value within 24 plus or minus 0.5. Is this a better scenario?
Better than the previous, sir.
Exactly. So customer expects whatever is the room temperature, that should reflect in my air conditioner display also. Then only I will consider the product as the best quality product. You can also use the other words, right? So ultimately, if the variations are minimal, that means your product is performing according to the specifications. In fact, it is
like,
yeah.
It is like UCL and LCL, right, sir?
Exactly. Yeah, it is within the UCL and LCL. In fact, the more closer you are to the center, the more closer you are to the targeted value.
It's like nominal, yeah.
Yeah, your nominal. Your product becomes, really best in class. Your product becomes really world class. All right. So that's the thing. Process output depends on input, the process conditions, and the performed activities. Hope all of you agree with me.
Good, sir.
Organization must be customer-centric, process-focused, data-driven, and should develop effective people for long-term success.
Yes, sir.
They
Yes,
should not
sir.
settle with the ordinary people inside. Gradually, your organization should also become big, right? And the maturity level of the organization should also be very high. It should be very supportive to the continual improvement. So if you focus on developing effective people, automatically your organization will also become effective. Focus of Six Sigma is to improve the process effectiveness. Six Sigma reduces defects by reducing variation.
Yes.
Good, sir.
I reduce the variation on the output by reducing the variations in the input side, right? Focus of Lean is to improve efficiency, but without compromising the effectiveness.
Yes.
I wanted to ensure the resources are consumed wisely without any compromise on the quality on the other side. Focus of Lean is to reduce waste by eliminating the non-value adding activities. Any unproductive activity, any form of inefficiency are known as wasteful activities, right?
Yes.
Sigma level is a measure of process effectiveness. Higher the sigma level, higher will be the process effectiveness. Higher the sigma level, higher will be the success rate. Higher the sigma level, lower will be the rejection. If your sigma level is 6, success rate will be equal to 99.999. That means the rejection is less than 3.4 dpmo. An effective process will produce defect-free output. An efficient process will consume only the required resources. It never consumes resources in excess. And resource can be, you all know, time is also a resource. Hope all of you agree with me. Time is also a resource. The floor space you occupy, that is also a resource. The effort your process is consuming, that is also a resource. You can always think of two different processes. One requiring more effort, other one requiring less effort. Which one you will call it as efficient?
The more.
One with
The one
less.
who requires more
One with
effort.
the
Which one requires less time to do it, sir?
Let's say we complicate the training, make it tough for you. Are we efficient now?
No.
No. But we simplify the job. You can quickly grab everything. And now we are efficient. Right? So efficiency means less effort is also a form of resource. That is what I'm trying to say. Never try to consume excessive resource. Number of defects that might occur from a Six Sigma process is 3.4 dpmo. A Six Sigma prescribes DMAIC methodology to improve existing products and improve existing services through process improvement. It prescribes another methodology called DMADV. If you wanted to create something completely new, you are bringing something new to the world. The world doesn't know such thing exists so far, but you are bringing something new. It's a birth-giving process. You can develop a new process. You can completely come out with a new design. You can completely come out with a new product, or it can be, new assembly line or a new product line, anything that is new, a new way of hiring process. That is a DMADV project, right? That's called DFSS. The green belt is a part-time role. Green belt can lead Six Sigma project. Complexity should be either simple or moderate. Some green belts also work as a team member. The black belt is a full-time role. Black belt can lead complex projects, cross-functional projects, right? And I say project is complex because, the challenges involved are many. The number of departments involved are many. Even the number of root causes can be many, right? So the complexity is high. The project is considered for Six Sigma if the problem is recurring in nature. Many times people confuse here. Sir, I have, I'm handling so many projects. The first project and the second project are different. Can I use Six Sigma there? Just think at the process level, not at the project level. You will not be able to apply anything, right? Think at the process level. Check whether the process is repeatable in nature. If the process is repeatable, that's the time problem will also become repeatable, isn't it? If process is not repeatable, why do you worry about the problem? Try to do correctly, right at the first time. You have to be fully proactive. Don't try to use Six Sigma for a, as a corrective approach. If your process is just one-time process. See, if your process is one time, tell me which is good. Proactive is good or reactive is good?
Reactive.
Proactive.
Always proactive.
Process is only one time. Already I gave the example, your marriage. It's only one time. You cannot be, reactive or corrective. You must be proactive. You should carefully, make your choice. Otherwise, your life will be like that. Right? You have to be careful, right? But if the process is recurring, but after marrying a girl, there are many things which are repeatable in nature, isn't it? You apply Six Sigma there. Every week, Sunday is a holiday. You wanted to make sure your Sunday, always is enjoyable fully. And do apply Six Sigma there. Because it is going to be, recurring in nature. If the last Sunday was not good, next Sunday can be good. You can make it good. Do something in between. Right?
Up and down.
Yes. So, in Six Sigma, solution to a problem is nothing but assigning a value to the root cause. Assigning a suitable value to the root cause. Assigning a value to the root cause. The value is called level. You are setting a level. For example, the valve opening. Valve opening can be completely closed, partly closed, fully open. Any one of the three can be a solution to the problem. Right? So, assigning a suitable value to one of the X factor is known as the treatment. The treatment is otherwise called as solution. So, solution simply means we are changing one or few of the X. That is called, optimizing the X. Six Sigma is actually an aggressive campaign. It is always implemented at the organization level. Unless and until everyone is clear about what we are trying to do, it is difficult for any project team to produce result. At least all the people who are connected to your project, you are trying to improve a process, and all the people who are connected to the process, we have seen it in the CpCpk. Right side, customer, left side, supplier. So many stakeholders and over and above top management. Unless and until all of them are convinced about what you are trying to improve, and improvement is not an easy job. So that's why Six Sigma is always considered an aggressive campaign. All of us together will try to boost the profitability of the organization. For that purpose, we improve process by process. We eliminate failure by failure. And one day your organization will become failure proof. That day, we are ready to scale up our business. Right? Bill Smith is the father of Six Sigma. Dr. Michael Harry is the one who popularized Six Sigma. He made it, much more structured, belt levels and all those things he brought. And employees, the process owners, are otherwise called as internal customers in Six Sigma. Am I correct?
Right.
Right.
Okay. End user is coming under the category of external customer. He is outside your organization. Scaling up a business requires defect-free products as well as, effective people so that they can continually manage the show. Lean evolved from the company Toyota Motor Corporation, isn't it? So the important principles of TPS, it is actually the Toyota production system. We call it as lean. The basic principles behind TPS is focus on creating value. Focus on creating value. Don't just focus on making money. Money you will be making automatically, but your goal should be create value. Customer is paying you 1,000 rupees. Can you provide him or offer him a product which is having a value of 5,000 rupees? Customer will be happy about the purchase. He paid 1,000 rupees, but you are giving him 5,000 worth of a product or a service. And customer is happy. At the same time, you remain profitable. It's a win-win. It's a win-win scenario. And business can be successful even in a long term. Right process will produce right results. Orange tree can give oranges. Apple tree can give apple, right? So you need right processes in place if you are looking at right results. So make your people effective. Organization will very soon become effective, right? Because the message will spread. A culture will change automatically. Organization must learn through problem solving. Don't run away from problems. Face the problem. That is Six Sigma, right? So organization learn project by project. Every project supported, there will be a new learning. There will be a new knowledge. That new knowledge will help you to upgrade your existing process, upgrade your SOP, right? No upgradation in the SOP. You are following the same SOP last 10 years. Are you learning? You are not learning from your failures, right? And you are very adamant to change. No, change is also essential. So,
Sir, one query. Sir, all these statements are showing here are true, right? But at the right side, true and false, both options are there. So what it mean actually? Why it is there?
true only.
So false is also there. So that is.
I don't want to do it as a quiz to save time. I'm not allowing you to answer.
Okay. So at the moment, the statements are showing true. Yeah, all are
True. Because you are all trained already on all the statements. I'm only repeating. I'm not teaching anything new.
Okay, right.
Even if I don't say they are true or false, you will be able to find it out. Right? Yes, it is true only. Two important principles of the production system. One is right sizing the resource. Another one is monitoring. Both are important. If you are a businessman, yes, you will always try to provide, the exactly required resources. Am I right? Yes or no?
Yeah.
Yes.
You run a business and business requires resource. Since you have a lot of money, will you provide, all the money and allow everybody to consume anything that they want? No. Right size it. And will you be interested in monitoring? Yes.
Sure.
Same thing is required currently in your department also. Yeah? That this is the basic behind the lean. JIT, just in time. Right sizing. Jidoka, yes, visualization. Heijunka, leveling. Kaizen, continuous improvement. Standardization, SOPs. Stabilization, statistical control. These are all, the you can call it the pillars or the foundation or the tools of lean. Muda stands for wasteful activity. Muda is a Japanese word. Muda means waste in English. Technically, any non-value adding activity you do, any unproductive activity you do, or anything you do which customer doesn't want to see. Anything you do which customer doesn't want to see, or anything you do, customer is not at all interested. All of them are examples of Mura. Right? Mura, uneven loading. Uneven loading. Uneven loading is also a problem. If you load your resources unevenly, few resources will be overloaded, few resources will be underutilized. Both are not good for any organization. So that's called Mura. Muri, overloading. If you don't eliminate Mura, Muri will happen. Muri is overloading. If you overload a staff, he will be under stress. Am I right? If you overload a machine, do you think machine will also be under stress?
Machine will depreciate quickly.
Yes. So all the three you must try to eliminate. At least minimize to the best of your efforts. Try to minimize, right? That is Mura, and Muri. Taichi Ono, one who introduced the concept of 7 waste. Hope all of you know the 7 waste by this time. Yesterday you should have learned. Tim Wood. And he is known as, father of Toyota production system. Operational excellence is an approach to make any organization a market leader through customer satisfaction and profit maximization. All of you understand what is operational excellence? It is not overnight job. Tell me how much time it might require to make your company a market leader. Come on, please.
At times years also, sir.
Yeah. So how many years you think it is required? 1 year is enough?
No, 1 year may not be enough, sir. It's like at least 5 years, because basically we need to.
Yes, that's the time. If your company can start thinking about the next 5 years plan, that's the time Lean Six Sigma is required. If your company is talking about this month's sales and next month's revenue, still the maturity level has to go up, right? So operational excellence comes into picture if a company is talking about the 5 years plan or at least 3 years plan. And not just creating a plan. You should make everyone in the organization understand your plan. Security till CEO should have a proper understanding on what is the focus for the next 3 years. Whether they like it or not, you should make it happen. Then the journey has started. Those who do not like, they will leave. Those who like and those who are really capable, they will survive. This will happen in any case, in any organization. You can't, adjust with the gaps. Some point of time, we also wanted to really, become big, become world-class. For that, operational excellence drive is required. So, operational excellence is a monumental task. Because we want to make our company a market leader, it's not that easy, right? And everyone must be involved. And they must be guided through strategic initiatives, which requires leaders who are very good at strategic planning and strategic management. That's where the master black belts come into picture. Understand, all of you, the purpose of the belts in the organization? Statistically, quality is a function of variability. Agreed? Variability is more, quality is less. Variability is less, quality is more. Quality not only depends on variability, but also depends on central tendency. What is central tendency? Process average. On an average, if I randomly pick up 10 products, what is the average quality? The average quality itself should be world class. Do you understand what I am telling? If I come to your college and pick up an average student, the average student should be, one of the best students. Likewise, statistically, if the average itself, the average value of the sample itself is close to the target, yes, your product is really world class. So this is a statistical definition. You can't see it in the books. For best-in-class quality, central tendency should be on the target and variability should be less. Understandable? Central tendency should be on the target and variability should be less. In any business results, when I say business result or performance, I am talking about Z variable. Obviously, any management, the owner or the the top man or the the management board will be interested about the performance of the business. They are called Z variable. You should not confuse Z with Y and Y with X. If you are still confusing Y with Z and Z with Y and Y with X, and you have a long way to call yourself as a green or a black belt. Business performance means Z variable. Any characteristics that is harmful to the customers or Y variable. Take care of the Y variable so that the board members can enjoy their results. Hope it is logical. If you are troubling your customers, do you think your board of directors will be happy? They cannot be happy. They should suffer now, right? So Z is different, Y is different. And of course, Y depends on X. So Z variable means the business results, which the top management is expecting. Market share, is it a Y variable? Market share.
Z.
It's a Z variable. Unless and until your product features are good, your market share cannot be, better. So that's an Z variable. And the business results, business consequences, all of them are Z variable. Market share, share price, revenue, even your profit is an Z variable. Cash conversion cycle, sales volume, customer retention rate, all are Z variable. Can you see that, all of you? All of them ultimately depends on your product, depends on your product quality. Y variable, the characteristics of your product, or you can simply call them as output from your process or a service. I'm talking about the taste, I'm talking about mileage, I'm talking about strength, and all these things are Y variables. You can see somebody expecting all this. If somebody is waiting to experience all this, then it is Y variable, other than the top management, right? And it can be external customer, it can be internal customer also. For example, lead time. Your end user is not going to worry about, maybe lead time also he will be concerned. He will, if he doesn't get the product on time, if the lead time is more, then, that will destroy his satisfaction. X variable. Now we are talking about the input and the process condition. All right. See here, I have written something related to the course. Can you read out, one of you? These are all the inputs, right? That is going to build your satisfaction. Am I correct?
Yes, sir.
So stress-free learning. Do you expect that? Stress-free learning? Definitely, right? So what percentage of the training duration you remain stress-free? That's very important for your satisfaction. Course material that is given, the number of tools that we are discussing, the number of case studies that we are discussing. All these things are input. Finally, customer satisfaction will be your output. And if the output is great, we will have hundreds of students sitting in our class in the next batch. I'm sure all of you will bring at least 3 for the next batch. Yes, please do it.
Definitely.
I think this is what you have learned so far. Am I correct?
Correct, sir.
Yes, sir.
Some recapping I've done. Now with that, I'm going to take you through the measure phase. Or any question anybody would like to ask? Yes, I'm open to it. Otherwise,
sir, excuse me, sir.
yes.
Z
Somebody said
variable,
yes.
sir, Z variable and Z value are same, sir. In
No,
the
no,
previous slide.
no.
Okay.
Statistically, G score is different. That we are yet to teach.
Okay, fine.
we have not taught that, right? But right now, the Z variable is considered as the business performance measures, right? The business results.
Okay, sir.
Good
Thank you.
question, but we'll be teaching it little later.
Sir,
Thank you,
this project hopper is a part of define or it will come in major?
Define. Project Hopper is in fact, if you ask me, that is part of a phase even before define. That is called, recognizing the need for Six Sigma, recognizing the need for improvement. If you are creating a list of improvement projects, right? What does it indicate? You now understood continuous improvement, is required in your organization. You identified all the issues. Now you have a list. Now every project in your list, the project charter must be developed. You will be learning about a phase, generally an organization that will be going through in the advanced program. We call it, MBB program. That is called recognize phase. Your organization, including your top management, will recognize the need for continuous improvement. They are fed up with, falling down and again and again and again and again. No, hereafter, no more falling down. Any learning, any improvement, we will sustain it. Thereby, we will become failure proof. Good.
So I have two questions. Yeah.
Yes, sir.
When we took a project for like the process variation, so during the our project execution, so we may there is a positive impact on the some other wastes actually. So in this condition, we can consider
Some of the
like some other waste actually. There is an impact on the positive impact on the other waste actually. Like there is additional impact like we going to like we are reducing the like process variation and overproduction or something else actually. In this case, we can consider as a Lean Six Sigma, right? Or inventory.
very simple, right?
Yeah.
If your project reduces defects, helps in reducing the defects.
Yeah.
Six Sigma project.
Yeah.
If a project helps in minimizing the waste, Lean project. If your project helps in minimizing both,
Lean
Six Sigma project.
Okay. The second question actually, like when we are executing the project, actually, I think somehow we got failed actually. Somehow we are unable to achieve the our
Results.
what we defined as a result. So
Okay.
how we can tackle it is actually.
Yeah. See, this is, there is something called intervention. If a team is working on a project, definitely the top management will be, doing the intervention. Like at the end of the define phase, they will come and verify. That is called a toll gate review.
Okay.
If you have not defined well, do you think organization will continue supporting? They will. They may even kill your project.
Exactly correct. Yeah.
So so you yourself intervene. You realize, results are not going to come.
Okay.
And probably, you yourself can propose closing the project. But if you don't figure out all these things in advance, the project will miserably fail, and that will be a loss to the company.
Correct. Okay.
But then Six Sigma project involves challenges that everybody knows. But at the same, it doesn't mean that we cannot deliver result. We can deliver result.
Okay.
But
Can I come, sir?
there will be challenges. Yes, sir.
Please note, your question was, what will happen? What should I do if what I expected did not come? Yes or no?
Yes.
Right?
Yes.
And that is what we are having Six Sigma projects. In
No.
order to prevent that only, we are having Six Sigma projects. So what are we doing? We are planning. We are logically planning. We are strategically planning. Yes or no? We are going in a particular order. Unless otherwise you have the signatures of all the people, project charter, you don't start the project. You are putting a block there. Once again.
Yeah.
And then what happens? You are really finding out the gap. There is an improvement or not. Yes or no? So only if there is an improvement required, you are going ahead.
Okay.
And then you are implementing a pilot study. There you are finding out the output. How do you find out the output? By measurement. How do you control the output? By measuring the inputs. What is the control chart playing there? You are ensuring that the inputs are maintained at the same level. If you are not maintaining the inputs at the same level, you know very well that it is not going to happen. The final result is not going to come through. Yes or no? Yes or no?
Yeah.
Right? Don't say that in spite of that. In spite of that means you're not done the planning properly. Right?
Yeah.
Therefore, the
Yeah.
moment the control chart tries to waver, it is giving you a warning that there is something wrong. Immediately what you do? You replan, reschedule, redo it. This is what we call PDCA. Plan, do, check. And if what you have planned is not coming through in the check, again, plan, do, check. This PDC is a cycle. Understood? Only after you have checked and the performance is obtained, you can go for acting. What do you mean by acting? You put it in the system. Clear?
Okay.
Till then, you are only doing PDC. So if you don't get what you expected, again plan, do, check. Right?
That is why we should respect all the principles we are learning here.
Yes.
It
Like
is like
while setting,
examination, yeah. You are studying, you write the exam, you fail, what do? Again you study, yes or no?
Yeah.
Again you
That
write the
worst
exam.
case study need to carry it out actually. Worst case study.
Yeah.
Yes.
In life, everywhere it is the same. In life,
and
everywhere it is
also,
the same. Right?
goal should be smart.
Yeah.
When I say goal should be smart, what is A there? Tell me what is A stands for in smart.
Achievable.
Achievable.
You should think twice before writing something in your charter.
Correct.
Right? So do have always have some reference and ensure it is achievable, and you can try to achieve. But in real time, yes, projects will fail. Sometimes we have to face the situation. All right. So
Sir, one comment. I will not take much time. Sir, just to mention, this project hopper is to recognize the project. If I have 4 5 Kaizen kind of project, and from which I will achieve the customer voice. So to select that which is very much impactful. So for that perspective, this project hopper concept is used.
Project hopper creates only pipeline of projects.
Okay, 1, 2, 3, one after another.
There will be list of projects. If you make the list in the order of priority, how will you arrange priority? What kind of impact every project will make?
Base is the criticality of the project.
Based on the criticality. That means organization priorities are there. You will have 2, 3 priorities. To what extent every project is impacting those priorities? Right? So accordingly, you have to rate it. And again, there is prioritization happening. So that is again, role, the responsibility of the quality council. As a green or a black belt, yes, you are responsible for driving the project towards success, leading the project. But in what order executed? Who will decide? A committee. The committee is called Quality Council, or sometimes Business Excellence Department, or sometimes it is called Lean Six Sigma Deployment Council. Right? So, but there are some tools you need to learn there, so that you can prioritize in an order which is acceptable to the organization.
Okay, so can we touch that tool in this course, or time permit us or not?
No, that we are not going to touch here, but it's because that requires understanding on the strategies. We need to talk about enterprise-wide planning, and what is a strategy, what is a long-term plan, what is a mid-term plan, what is short-term plan. Whether the short-term your project is out of short-term plan. The short-term plan should hit the long-term plan. So nothing but some KPIs. So, but anyway, the flow is very important to understand the subject well. So you will be learning it in the MBP course. All right. So
it's more towards sponsor side and champion side, I can say. Yeah.
Very true.
Thank you, sir.
So measure phase, toll gate review, measure phase, steps deliverable. I think this was taught to all of you. I will only show you the questions. Measure means you should have a clarity on the CTQs. You should have a data collection plan. your measurement system, the equipment you are going to use, people who are going to involve, the environment under which you are going to collect the data should be capable. Otherwise, errors will populate. If the errors populate with too much quantity, then your data will become an useless data. Garbage in will become garbage out. You have to be very careful. And data collected should be appropriate for analysis. Appropriate in the sense, it should be clean and credible. Clean means measurement error should be less than 10%. Credible means it is collected from a reliable source, right? So that the confidence level on your decisions can be taken care. Otherwise, your decision, whatever you arrive, may not hold good in real time. And how far is your project goal from the current performance, the performance gap? When do you come to know about performance gap? If you know the baseline. Baseline is correctly understood. Goal is already fixed. The difference between the baseline and the goal, that is called the performance gap. What is the reason for the performance gap? It could be either because of defects, or it could be because of waste, or it could be because of risk. Now, what is the source of defects? Variation. What is the source of waste? Non-value adding activities. What is the source of risk? Failure modes. You work on all the three. Defects will come down, waste will come down, risk will come down. Automatically, you will see your results going up, right? So we will be analyzing about the reason for the gap in the analyze space. Right now, how much is the gap? That is the question. That is called baseline performance. So data collection plan, validate the measurement system, and measure the baseline performance. And main deliverable is baseline performance. Baseline can be any metric that can help you understand the success of your project. Any metric that can help you. Sometimes it is rejection rate, sometimes it is DPMO, sometimes it is CpCpk, sometimes it is lead time, sometimes it is strength of a material, sometimes it is customer satisfaction score. Whatever it is, what is that you wanted to really improve? What is the baseline of it? That is the deliverable. And these are the tools at the initial level. Of course, there are some advanced tools you will be learning as you move up and progress in the course. Operational definition. Is that operational definition taught to all of you? Please confirm.
Yes, sir.
Okay. That means what is that you want to measure? A clear definition must be available. And then data type, continuous data, discrete data. Hope all of you studied that also.
Yes.
And then bias, repeatability, reproducibility, gauge R&R. I am going to talk about the second part now. Measurement system validation. Is my measurement system good to go? If I use this measurement system, is my data become reliable? Right? Can I take error-free decision, or will I be committing errors? Type 1 error and type 2 error and all those things we are going to talk about. And then in the afternoon, you will be learning about the traditional yield and first pass yield and all those things. All right. So data collection plan means data type, and then operational definition. And finally, we will be having a plan. So identifying what is to be measured. What is to be measured? CTQ is to be measured, critical to quality characteristics. Right? CTQ is your Y variable. If you have the information about the X variable also, you can collect data about the X also. Otherwise, later on you will realize X also required to be measured, and so you will collect data about X also. And then data collection plan, data type, and operational definition. So what is CTQ? Key measurable characteristics whose performance standards or specifications must be met to satisfy the customer. Right? It will have a target, it will have an upper limit, it will have a lower limit. The target is sometimes called nominal, upper limit is called upper specification limit, lower limit is called lower specification limit. Am I right?
Yes.
What is the targeted time of completing today's training?
5.
So
5 p.m.
classes.
Suppose we stretch it beyond 5 p.m. To what extent you all will be, tolerable?
30 minutes.
Oh, half an hour extra we can teach, right? I hope yesterday it happened, right? All of you remained patiently. Good. That's a good, culture, I would say. So 5 o'clock, if it goes up to 5:30, yes, all of you are ready to, accept it. Similarly, if we close it early, what time we can close?
See, we can have the same sigma levels, 4:30 to 5:30.
4:30. So the 4:30, any time between 4:30 to 5:30, if we close the training, it is acceptable to all of you. You have defined it.
Yeah.
That is called a customer requirement on a particular CTQ. It doesn't mean, the entire training went on well if you close on time. No, there are many other things to be looked at to say, no, the training is excellent. One of the CTQ is schedule, complying to the schedule. So 4:30 is the lower spec, 5:30 is the upper spec. But it is always good, staying around 5. The same is, logic is required. You should have a clarity on your CTQ. It can be diameter, it can be length, it can be surface finish, right? It can be, the report accuracy, whatever it is. So whatever is the customer requirement, always there will be a target, there will be tolerable limits, which are called as specification limits. It will include upper spec and lower spec, like, Swiggy or Zomato. In Swiggy or Zomato, what is the CTQ for a business like Swiggy or Zomato?
Delivery time.
Delivery.
Every time you book a food in Swiggy, will it show the expected arrival time of the food?
Yeah.
It will say 30 minutes. What does it mean? Is it the targeted time?
Yes.
Yes.
You are wrong. It is the upper specification limit.
Upper limit, yeah.
Maximum tolerable limit is 30 minutes. If the food doesn't come even after 30 minutes, what will you do? You will cancel.
Complain or
You will
You will
cancel
not
and
pay
you
for
will,
it. Cancel.
you will definitely raise a complaint. That means the 30 minutes is upper spec. What is the lower spec in this case?
As soon as he delivers.
It can be as low as 0. But 0 means food is coming from your neighbor's house, not from Swiggy. Practically, it is not possible, right? So maybe, you can have some assumption in that case. Maybe 10 minutes it might take. Even though it says 30 minutes, you can expect the food to come maybe any time between 10 and 30 minutes.
Plus or minus.
If you are clear about upper spec, also lower spec, then center point is the target. Center point is the target. So Swiggy has designed a process in a way that food can be delivered in 20 minutes. That's why the app is committing, 30 minutes. Even something goes wrong on the way, still food will arrive within the specifications, right? So that's the understanding about CTQ. Now there are 2 types of data, and this is a definition. I'll go with an example, right? So data can be of 2 types. It can either be qualitative or be quantitative. If I ask all of you, what is your name? You all will tell me your name. I will type it in an Excel sheet. Is it a data?
Data only.
Data. But that data is qualitative or quantitative?
Qualitative.
Because it doesn't have any number. But what can I do with all your name? What do I understand by seeing the name? I know you're all separate individuals. That's all. That much I can understand. One is different from other. For that purpose, a name is given. Such kind of data are called qualitative data. It only helps in differentiating. That's all. You can't try to perform any mathematical operation. If I add Venkat Subramani and Srinivas, will it give Ashok Kumar? Not possible. Mathematics is not possible. You can only have some differentiation. Like, how we differentiated X, Y, and Z. That is a qualitative data. I am collecting all your age. Now the data is quantitative. Now I know who is elder, who is younger. Right? So I can order the data. Right? And the elder people on the top and younger people in the bottom. And now again in the quantitative data, there are 2 types. One is discrete, another one is continuous. Continuous means measurable. Discrete means countable. Continuous means measurable, discrete means countable. I want to know your weight, each one's, weight. Is it measurable?
Measurable,
Yes.
Then it is continuous data. Anything you measure, it will have a unit of measurement. Your weight will have a unit of measurement. What is the unit?
Yes.
kg.
kilogram, degree Celsius, seconds, minutes, days, kg per centimeter square. These are all continuous data, measurable. There are measuring equipments available using which you can measure and your reading will come with a proper unit of measurement. That is continuous data. It is called continuous because any number of decimals is possible. Any number of decimals is possible. That is why it is called continuous. You can't say only, this value will come. Any value will come. So it's called continuous. On the other side, I want to know how many people are now attending the session, keeping the video on. How many people are there on video in spite of the request? How many are currently on video? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people. Now including Nilesh, I should include you or not? Yeah, I will include you. 10. How did I get the number now? This is also a data. How many people are on video? This is also a data.
Discrete data without decimal.
Countable.
Countable.
Number of units rejected every shift. How do you know? Somebody counts and telling you. Somebody will be counting the rejection and telling you. So those are called discrete data. Whenever you count will only have numbers, no other unit. I cannot say how many units rejected. I cannot assign a unit. It is only number. All of you understand the difference between continuous and discrete? Number of children in your family. Is it measurable or countable?
Countable.
Very good, right? Now you all know what is continuous and what is discrete data. Turnaround time, is it measurable or countable?
Measurable.
It's a
Measurable.
So it is continuous. Customer satisfaction score.
Sorry to interrupt you, but these slides has been taken by I think Dr.
Understand. No problem. We will just quickly move. And customer satisfaction score.
Score is countable, discrete.
Because only if no decimals or we are avoiding decimals. We are only keeping whole numbers. Number of failed transaction.
Discrete.
Maturity amount.
Continuous.
Total available balance in your bank account.
Continuous.
Time to resolve a complaint.
Continuous.
Number of credit cards that are linked to your savings account.
Discrete.
Time taken to process a loan application.
Continuous.
Number of clients attended.
Discrete.
Now you are expert in data type. Right? You know qualitative, quantitative, continuous data, discrete data. And unit of measurement and operational definition. I think you all have studied in your undergraduation, post-graduation, the appropriate unit for weight, time, and pressure, temperature, everything, right? You can choose the. But what is very important during data collection is if there are 10 people collecting the data, all 10 people should have the same definition. And all 10 people should use the same unit of measurement. If I am measuring in minutes and you are measuring in seconds and using the data for a purpose, we might be misleaded, right? So all of us should follow the same unit of measurement. Operational definition, a clear, understandable description of what is to be measured and what is to be observed, right? Irrespective of whoever is reading the instruction, everyone should have the same understanding. If there are ambiguity, if you are using confusing words, that is not operational definition. This is not SOP. SOP is different. Operational definition is, purpose is different. Here, we are giving instruction on how to collect data. Then it is called operational definition. For example, how to hold the workpiece, how to hold the measuring equipment, right? And what should be your posture during data collection, whether you can sit or you should stand. All these things should be clear. And if required, some images, some diagrams, some video clips can be provided. Everything together is called operational definition. Ultimate purpose is we want error-free reading. You can see the operational definition of various CTQs here. These are all related to a restaurant, process related to restaurant. Can you see that, all of you?
Yes, sir.
Yes, sir.
Can somebody tell me what is the definition of customer waiting time according to the definition given here? Please read through the last definition and let me understand what is the meaning of customer waiting time in a particular project that is defined there.
It's the total time a customer spends at the joint from the time he enters the outlet to when he served the meal.
When he served the meal, is it written over there?
When he's seated, I think. no?
The seated.
The project is focusing on reducing the customer waiting time, and the process is allotting a seat, allotting a table to the family. If you enter the hotel and there will be, what do you call, a kind of waiting room, and there will be some restaurant manager who will be noting your name. By the time you enter the restaurant and when a seat is allotted to your family. This is the project goal now. We wanted to minimize that customer waiting time. And you can see customer waiting time, the meaning can be different in different projects. Am I right? In this case, the moment you enter the restaurant and the moment a table is allotted. That means any moment a customer comes inside by opening the door, you should start your clock. By the moment a seat is provided or you are seated, you should stop the clock. The time between start and stop, that is called customer waiting time. All of you understand? Because our project is aiming to reduce the customer waiting time. You should know how to measure the customer waiting time. All of you are clear with me?
Yes, sir.
No, sir, repeat these things first time.
Repeat the question.
Customer waiting times, how can measure?
That is, the definition is written. According to the definition, the moment somebody enters your restaurant, you should switch on your stopwatch. The moment he is allotted a seat, you should stop your stopwatch. Now your stopwatch will show the waiting time. Do you understand? You might have experienced, every time you go to some big restaurant where, always there is a crowd, you will experience this. Am I correct or not?
Yes, yes.
Sir, sorry, one small clarification. See, we have now differentiated the customer waiting time with the order lead time. Ideally speaking, as a customer, layman customer, I would like to get the orders first. I see waiting time is fine, but I understand the project differentiation, but I'm just saying this both the customer wait time and order lead time join hand to hand, right? Ideally speaking.
Yeah. See, order lead time also includes customer waiting time.
Correct.
Order lead time means the time between order and food is delivered.
Yeah, but here, sir, can I in between? But here
yes.
in this case, this is an example of operation definition. If I, as a leader of the project, if I want to see the waiting time of in this definition, so it is from enter to seat allotment. This is only I have to take care, right, sir?
Yes, true. See, your scope of the project is limited to customer waiting time and not lead time.
Correct.
Lead time is out of scope because if you want to control the lead time, then you should go to the kitchen also and look at what is happening in the kitchen. You should look at how the server is performing. You wanted to scope out all those things. So your project is limited only to customer waiting time. But you will be parallelly running other projects also. I'm not saying that you can ignore. Venkat Subramanian is correct. You need to run other projects also. And how the cooking is happening. Can I do something over there? Can I minimize the cooking time? Can I minimize the preparation time? Can I pre-cook some of the foods and make it available without compromising on the quality? All these things, can be thought about if you wanted to maximize your business with the available resource. You got only 100 seats in the restaurant, but you wanted to increase the revenue per seat. Revenue per seat. Per seat per day you want to maximize. Then you have to improve all this. Then only it will improve. Because when you are keeping people in the waiting room, revenue per seat will not increase. That is, unnecessary, non-value adding. Am I right? Making all the visitors waiting in a waiting room. It's a non-value adding. How many of you can realize that?
Yes, sir.
Yes, sir.
You have a manager doing some work there. The fan is running, AC is running. Can you charge your customer?
Space.
Definitely no.
Thank
So
you, sir.
data collection plan, according to what you are really trying to improve, you should collect data. What came was so CTQ definition or CTQ, what are the CTQs you want to monitor? Its operational definition, where from the data must be collected. Customer waiting time means data must be collected from the waiting room, not from the kitchen. Isn't it? And then sample size. How much data, how many data you want to collect? It should be adequate enough so that the sample can be a good representative of the population. It should be adequate enough so that the sample can be a good representative of the population. All of you agree with me?
Yes, sir.
It is 5 sometimes, it is 10 sometimes, it is 100 sometimes. You have to understand, right? And who will collect the data? Are you the one who will be collecting the data, or are you going to assign the job to someone else in the project team?
Sir,
Please
one query. One query. Any tool to judge the sample size of
Yes.
particular task? Any
Yes.
tool is there, sir?
Yes, tools are there.
Okay, we'll go there. Okay.
Tools are there, right? And then who will collect the data, and when will the data be collected? Do you want to collect data from all the shift, or is that the problem is happening only in particular shift? If you are very sure problem is happening only in a particular shift, ensure you collect data only from that shift. That will make more sense, right? And then how the data must be collected? Do you want to do a random sampling, or do you want to do a systematic sampling, or you want to go for a cluster sampling, or you want to go for a stratified sampling? And I cannot prescribe anything unless and until we work on a project. We can't prescribe this is good. But ultimately what is required is your sample should be a good representative of the population characteristics. Whatever characteristics you observe in the sample, that should be close to the characteristics of the population. For that purpose, you decide, you choose, you are given the rights because you are the green belt, you are the black belt, you are the project leader, right? And how much data you can collect at a time. This is called subgroup size. How many data you will collect at a time. Always collecting data in group is a good idea. That's called subgroup. Subgroup size generally varies from it varies from 2 to 30. 2 to 30, and there is a logic behind that. If you collect data in subgroup, the chance for your subgroup statistics to follow normal distribution is very high. I repeat the statement. If you collect data in subgroup, the chance for the subgroup statistics to follow normal distribution is very high. Let us say subgroup average. Subgroup average, if you plot, it will look like a bell curve. We are basing all our decision based on normal distribution only. So try to make your collected data exhibit normality. So that's why I said it is always a good idea to collect data in subgroup, right? So ultimately a sample, yes.
So each subgroup can have a different sample size or same sample size.
Okay. No, generally, yes, your subgroup size can be constant, can be variable, but generally for a continuous data, subgroup size must be constant. But for discrete data, your subgroup size can be different. Do you understand, sir?
Yeah.
If your data type is continuous, try to keep the subgroup size constant, right? And if the data is discrete, then it can be no different, and accordingly different control charts are available, you can monitor. So ultimately a sample is a subgroup taken from the population, and it must be a true representative of the population. The sample characteristics must help you to judge on the population characteristics. Now one of you tell me what is sample characteristics and what is population characteristics. Are they same or are they different? Come on, please.
Sample is a representation of the population.
Okay. Sample characteristics means what do I mean about sample characteristics?
It is the CTQs.
CTQs. So how the CTQs are in my sample? That is what I'm trying to check, isn't it? how the CTQs are in my sample. Let us say I'm using, some rod, metallic rod. In a rod, what are the characteristics? What are the CTQs? Length of the rod is important.
Diameter.
Diameter is important.
Length.
Strength is important.
Length
So you
is
have taken
important.
10 samples and you are collecting, or you are measuring length, you are measuring diameter, you are measuring strength. Does it mean whatever you observe in the sample is the same thing going to customer also? Tell me. I'm measuring 10 pieces and I'm happy with the 10 pieces. Can I now dispatch the entire lot I produced on the day?
Yes.
As per
Yes.
the requirement of the
All that required is your sample should be representative of the population. Just measuring 10 pieces, you are taking decision about 10,000 pieces.
No, no, sir.
Yes, it is.
That is the
Yes,
point
sir.
of
Sir,
having a
without
sample analysis. Yeah.
quality.
Yeah.
Random sample
Sample sizes.
analysis.
It happens in industries. Sometimes it happens in that way, right? They produce so many pieces and they only check, hardly 20, 30 pieces. And then, a decision is taken whether the population is good or bad. Now,
Similarly,
what
the
is very well,
quality.
that is why we talk about measurement error. If somebody measures wrongly, your decision can go wrong easily. We don't want to fall to that mistakes. That is why we try to control measurement error. That is also the reason why we are trying to control the sampling error also. All right. So if you can minimize the error, yes, you can take decision even with a sample of 10 units to judge about 10,000 units. Right?
Sir,
Full
I have a question.
characteristics. Yes.
For example, we have gone for 10 samples, random samples from 10,000 units. So what percentage we should get to approve the sample population? Percentage of rejection.
That means, I could understand. All of you are concerned about the sample size only. Am I right? It depends on your confidence level that is required to arrive on a decision.
Sure.
Maybe RK would like to add some points here. Yes, sir.
Please note, you have 1 year. Yes or no? 1 year. All of you know 1 year?
Yes.
Yes. 1 year has got 12 months. Yes or no?
Yes.
And each month has got 30 days.
Yes, sir.
Right? You want to prepare for your examinations. You will prepare for year or month or days. Daily you will prepare, or last month, last 2 months, last 3 months you will prepare, or last 1 year, last 2 years you will prepare. You want to become a doctor. Your parents want you to prepare for every year, right from the day you join. Yes or no? What is the subgroup size? 1 year. Right? You want to prepare for your current examination. Now each month you will prepare. What is your subgroup size? 1 month. Yes or no?
Yes,
You
sir.
want to prepare for this month examinations. Your subgroup size is 1 day. Every day you will prepare. Yes or no? Subgroup size depends upon the application. Right? Suppose I want to find out whether Modi will become a prime minister or not in the next election. What is the population size? It goes to the Indian population. Yes or no?
Yes.
Now, what could be the subgroup size for that?
No.
Each state. No, subgroup size is there for everybody. Even for infinite populations, you can define the subgroup size. Right? Understand? That is the beauty of statistics. Right? Probably it will say lakhs. I don't know. Right? You take a lakh sample, 1 lakh sample, that is from each state, take a fixed amount of that is how they are giving the results, report results. How do they give? They are giving, no. Every year after year, no. When before the election results are out, they give the election results, no. They say that they will come and they are coming. Whatever they say. How do they do it? They are doing only sample, right? When they take a sample, they definitely will have a sample size, right? It goes not more than 2,000 per area. All they do is they telephone, just like that randomly they take a telephone and then say that, well, what is your opinion and things like that. They will ask, and then they will make the survey results, right? Therefore, sample size is a function of 3 factors. Now, suppose you want to get an output in a coffee, as you say, right? What you will do, there I'll take only three factors, right? Water, that is water, milk and coffee, right? Black coffee I'm taking, right? So only three factors are there. Yes or no? How much coffee powder required, how much water required, how much what do you call, whatever is the milk is required. You can do it by doing experiment. Yes or no?
Brand mix.
Right. Therefore, in order to find out the sample size, you will have to conduct experiments based on these factors: coffee, sugar, and the three factors here are the interval you want, that is the accuracy you want, right? Between this point and that point, that should be 3%. And the confidence you want, that is 95%. And how the population is distributed, the normal distribution is a factor, right? So these three factors are known, then you can find out the sample size. There are very many calculations are there. Different people are given different formulae based on these experiments. And for each factor, how many experiments you need to find out the effect? If it is linear, you need only 2 experiments. If it is curvilinear, quadratic, you need 3 experiments. Is this clear? This point. Only how it is varying, you keep one level, you keep another level, draw a straight line, so linear relationship. And if it is a curvilinear, you take 3 points, one level, another level, third level. What is the point? Draw it, you will get a curve. Yes or no? You know the variation of output with respect to the input, curvilinear. You need 3 experiments. Yes or no? Yes or no?
Yeah.
Yes, sir.
Right? Okay. Today, I conduct a test and RK scored 50 marks. Right? Day after tomorrow, I conduct a test. He is scoring 60 marks. So, day after tomorrow. Today, 50 marks. Day after tomorrow, 60 marks. So, tomorrow, if he writes the exam, he will score 55 marks. Yes or no? Yes or no?
Correct.
Because that is what is showing linear. But if I conduct the experiment tomorrow also, if he is not showing 55 marks, he is showing only 56 marks. Then it is a curvilinear. Right? Is that curvilinear? So you can find out the relationship is linear or not linear by conducting 2 experiments or 3 experiments.
Yeah.
Okay. So 3 experiments are required for 1 factor. How many factors I said? 3 factors are there. So 3 into 3, what is 3 into 3? 3 times 3? 9. 9 times 3? 27. So 30 sample size is minimum required for anything. Yeah. Minimum sample size required is 30, unwritten rule. Yeah. And then more than 30, when do you need? When the population is large. When the population is large. Therefore, sample size is a tricky calculation. This course cannot teach you that, not because that it is not in the syllabus, not also because it is requiring more amount of time for you to practice, right? But RK will give you a template which will give the sample size in just 1 second, for which you need to spend 1 year, right? Don't worry, we will give it. Only thing is you will have to ask for it. I'll put it across. You can use the sample size template and ask Vision Excellence. I will put it there also. Right? Thank you very much. Please.
Thank you, sir. Please share this template.
Yeah. The template similarly, Minitab also has got a feature to calculate the sample size, but the purpose of sample size has to be very clear. Then sample size can be, recommended. But if the purpose is not there, the thumb rule is 30, right? So that's how it is. But we'll be, talking about the sample size again when we cross that. Now, we are going to talk about measurement system analysis. Can you tell me what is the meaning of measurement system analysis? What is the meaning? What is the broader understanding of MSA?
Cross-check whether the measurement is correct or not correct.
Whether my measurement system is usable or not.
Usable or not. Okay.
Yeah. When I say measurement system, it includes several elements. Can somebody tell me what are the elements inside a measurement system? Measuring equipment is definitely an element inside your measurement system, right?
Yes, sir.
Measuring equipment.
Parameters.
The yardstick that you put.
Parameters.
Yardstick.
parameters.
What do you mean by sir yardstick?
Any
Parameters.
threshold or any calculative techniques.
Standardization.
That is your operational definition you are saying.
Yeah.
The person making the measurement.
Very good. The person making the measurement. He is also an element in your measurement system. He can also sometimes become the source of error. Yeah.
Competency of method
And the
is called
sample. And the sample.
Is called appraiser, and the sample itself. Very good. If the sample is very too small, you can't hold it. That could become a source of error, isn't it? So sample itself is an element. Environment. Environment is also part of your measurement system.
Right.
Methods. Method.
Yes, the method used. That is covered in the operational definition. Yes, the method used. So if anything goes wrong, your data can go wrong and your decision can go wrong. You should know that, right? So bias, repeatability, reproducibility, and then gauge R&R. This is what we are going to talk about. What is bias? Okay, before that, and it is like, we are relying on data. Like while driving a car, we are relying on the windshield, isn't it? The whole journey, we see the road through the windshield. Can you keep the windshield, fully dirty? You can't.
No.
If it is dirty and you can't see the road, then you are creating a risky journey. Same manner, if your data is also dirty, your journey, will be very risky. All your decisions can go wrong. In fact, you can't even reach the destination, which means you can't, produce the result. You might say you produce the result, but in real time, there will not be any impact. Simply because their measurement system is wrong, right? So, which is very important. You have a clear vision of the road while driving a car. Same manner, you should get a clear vision of the problem while reading the problem through data. Your data should be clean, right? So MSA is to ensure your data is clean and credible, right? You can see the problem better, understand the problem, after conducting the MSA. Now, when I say measurement system analysis, we are concerned about two things. One is accuracy, another one is precision. Measurement system analysis means accuracy, another one is precision. When I say accurate, what does it mean? How is it different from precision? When I say accurate, what does it mean?
Accurate is exactly
near
what
the
we-
target.
Near the target.
Exactly the
Not-
target.
Better word, instead of using target, use true value. True value.
Represent true value.
True value. Closeness to the true value. If you are on the true value, you are accurate. If you are away from the true value, you are inaccurate. Make sense?
Yes, sir.
100 mm is the specimen. You are asked to measure and you are also saying 100 mm. Are you accurate now?
Yes.
Definitely accurate. Suppose you say it is only 90 mm. Now you are not accurate.
Not it.
Your reading is away from the true value. How much it is away from the true value? 10 units.
10 mm.
100 mm is the true value, but you are saying 90 mm, 10 mm. This 10 mm is called bias.
Sir,
This 10,
tolerance can be applied for accuracy.
tolerance.
Plus or minus.
Tolerance is,
Tolerance is there.
no, you can express your accuracy as a percentage of the tolerance. You can express your bias as a percentage of the tolerance. Do you understand?
Yeah.
Any measuring equipment will have a tolerance. If I say my measuring equipment is plus or minus 0.5, what does it mean? You can expect a bias of 0.5, isn't it?
Yes.
So plus or minus 0.5 means you can expect a bias of 0.5. But how much is this bias with respect to your working range? That is important. You are buying gold, 0.5 gram bias. Are you okay?
No.
Are you okay to compromise 0.5 grams?
No, no, no. That will be accurate only. We need to be accurate.
Because it is gold, 0.5 gram is unaffordable. If they say 0.05, maybe it is affordable. Or you may even expect a better equipment, 0.005. So always understand, your working range. With respect to the working range, if the bias is less than 10%, industry guideline is okay, acceptable. But more is perfection is better always. If the bias is 0, that's the ultimate. Only to reach the ultimate, you think of calibrating your equipment. Am I right? You want to reach the ultimate, you calibrate the equipment. But even after calibrating, after some period of time, again it becomes inaccurate. That is why you increase the calibration frequency. Earlier you were calibrating 6 months once, and now you changed your calibration frequency to 3 months. Why? You want accurate readings. All of you understand? You can minimize the bias. There are ways. General practice is calibration. Calibration, frequency of calibration, and proper way of keeping up the equipments. All these things can minimize bias. Am I correct?
Right.
Another way you can minimize bias is taking multiple measurement. Your teacher could have taught you when you have did some experiment in the school or college. He might have asked you to do the experiment at least twice. Am I right? Yes or no? Have you done that?
Yes, sir.
He will not allow you to use the reading, just like that. He'll ask you to repeat the experiment 2 times, 3 times, and use the average of the experiment in your formula. Then only the G value will be close to 9.81. We know acceleration due to gravity is 9.81. In order to calculate the acceleration due to gravity, you require the mass of the item. You require the force applied. F equal to ma. All of you have studied, right? F equal to ma. What is that? Newton's first law or second law or third law? Even I don't know. I have forgotten. Force equal to mass into acceleration. So somehow, using that equation, you can find out acceleration due to gravity. Am I correct?
Yes.
And we know the globally known value of acceleration due to gravity is 9.81 meter per second squared. I want 9.81 meter per second squared. So I measure the force 3 times or do the experiment 3 times. I will have 3 readings for force. I will have 3 readings for mass. Calculate the average force, calculate the average mass, and F by m will give me acceleration. Am I right? When I do the reading 3 times, the chance for me to be accurate will be very high. So repeating experiments can minimize the bias. Logical. All of you understand why we repeat experiment?
Yes.
We repeat experiments to minimize bias. We can be more accurate.
It can
the same
be
thing is
validation, or this term also can be applied, sir. Validation.
Validation, or come again?
The term validation is also applied for this.
This is no. We are trying to validate our measurement system, and for that purpose, let me explain. If you want to validate your measurement system for accuracy, see here, there is a standard piece. There is a standard piece. What is the size of the standard piece? Tell me.
1 inch.
Very good. 25.4 mm.
Okay.
You are asked to measure the standard piece 10 times. You know why am I asking you to measure it 10 times? Is it because you are free? No. I want to validate the measurement system. I know when I involve you in data collection, will you give me a reliable data? For that purpose, I am asking you to measure 10 times, but I am doing a trick here. I am asking you to measure the piece at different time so that you don't know you are measuring the same piece. Do you understand what is the trick here? I am asking you to measure the same standard 10 times at different occasions without making you realize that you are measuring the same piece. Do you understand? Now you are giving me 10 reading.
Yeah.
All your readings are close to 25.4 but are not same. But the standard piece is same in all 10 occasions. And now I want to know whether your readings are accurate or not. For that purpose, I will calculate bias. When you have 10 reading, first thing you need to do is you should calculate average. Average of the 10, easy job, right? You add all the 10, divide by 10, what do you get? 25.4051. But what is the true value? 25.401. So how much is the difference between the average and the true value? 0.0051. The 0.0051 is the bias. All of you understand how the bias is calculated?
Yes.
Now my concern is, how big is the bias with respect to the purpose? For gold, you all told me, sir, 0.5 gram is too big. I can't afford. Isn't it? They can charge me unnecessarily. I don't want to afford it. Similarly, in this case, the process tolerance is plus or minus 0.25. Any piece that your company is producing can be 25.4 plus or minus 0.25. Can you see that, all of you? 0.25 on the right side, 0.25 on the left side. Totally, what will be the range? 0.5. With respect to the 0.5, how big is this 0.0051? All of you, can you see that? With respect to the 0.5, how big is the 0.0051? I understand it is slightly above 1%. Industry standard, earlier I mentioned 10% is tolerable. When I say 10% is tolerable, 10% of your decision can go wrong. Am I correct? 10% of your decision can go wrong. That's the compromise you are making. You are okay. You want to be at least 90% of your decisions will be perfect. All of you understand the bias calculation here?
Yes, sir.
So only the tolerance 0.5.
Tolerance, don't worry. Customer will give you.
Oh, they will give us. Okay, sir. Okay,
Upper spec, lower spec.
oh, that. Okay, sir. Got it.
Yeah.
Sir. Deviation.
Difference between upper spec and lower spec is 0.5. That is the denominator. With respect to the customer requirement, my measurement system has an accuracy level of, or as a percentage level of 1.02%, bias percentage.
Average.
If the bias is 0, that's the time you can say you're accurate. Or you can have a definition of accuracy. If the bias is less than 10%, you can say, your equipment's, your measurement system is accurate. That's the, industry practice also. But any time, if the error is more than 10%, it is generally not recommended. Right? You should require some improvement.
10% is the default value, sir, for
No, 10% is, the standard practice, industry standard, we say. And who give the standard? AIAG, Automotive Industry Action Group. They have created all these, references.
Also, it depends on the industry as well.
Yes. If you are within your company, if you wanted to, keep the measurement error less than 5%, if that is your norms, yes, that can be followed. Yes. But talking about the general practice is 10%. All right. And now bias, we understood. Bias should be 0. But if it is not 0, at least it should be constant. Make sense? Yes or no?
yes.
The bias is 0. Very good. No need to worry about anything. Measurement error is not at all there in the picture. If the bias is some value, at least it should remain constant. If the bias remains constant over time, your measurement system is considered stable. Am I right? I use the measurement system in the morning, use it in the evening, use it tomorrow, use it next week, use it throughout the project. Bias is constant. My project is 3 months. All 3 months, the bias remains constant. If the bias is constant, measurement system is considered stable. If the measurement system is stable, you can simply have a calibration table and you can make your readings bias free. Possible or not? Let's say you have a watch which is always running 10 minutes faster. I'm asking you, what is the time now? Your watch will show 11:15. But what is the actual time?
11:05.
How did you find out the correct time?
So constantly it is 10 minutes faster.
That is the advantage. If the bias is constant, if you keep your measurement system stable, you can either eliminate You can subtract or add the bias to make your readings accurate. It becomes an easy job. All of you understand what I'm speaking? Sometimes, in the measuring equipment, they will tell after taking the reading, you add this value. That value should be used. The reason is they wanted to eliminate the bias. The table that is helping you to eliminate the bias, that is called calibration table. Or otherwise, go for a full calibration of your equipment. That will also make your equipment accurate and bias is 0. The ultimate goal of calibration is bias should be 0. So this is one requirement. Bias should be constant over time. Bias should be constant over the range of reading also. Do you understand what I'm speaking now? Bias should be constant over time. Bias should be constant over the range of reading also. Let us say you are measuring, from 5 grams up to 500 grams. 5 gram is very small. 500 gram is half kg. And now you are measuring scale. If it can give the same amount of bias throughout the range, your measurements the bias is considered linear. Do you understand what I'm speaking now?
Yeah. Sir, once again, just repeat linear.
Linear means bias should be constant throughout the range of your reading. If the bias is constant, if you plot a graph of the bias, that will look like a straight line. Do you understand?
Got it. Got the point.
Same value continuously, sir. Like linear.
Like, you have reading from 10, 100, 1000. The range is very big. When the reading is 10, when the true value is 10, your reading is also 10. When true value is 100, reading is also 100. When true value is 1000, reading is also 1000. Now look at the 3 reading. Are your readings accurate?
Yes, accurate and linear.
Accurate, linear,
And linear.
bias is 0.
Bias is 0.
When it is 10, it is showing as 15. When it is 100, it is showing as 105. When it is 1000, it is showing as 1005. Now there is a bias, but the bias is constant. And now also it remains linear. Can you see that, all of you?
Yes, yes.
The distance between the true value and the observed value remains constant throughout the range. This is called linearity. Hope all of you understand by looking at the diagram.
Yes, yes.
Yes.
Suppose while measuring 100, bias has become 120. Now my reading is going like this. Now at the center, the bias is too much. This is generally not preferred. Bias should be constant. Bias should be linear. Bias should be stable. Right? You should know how your measurement system is behaving within the range. This knowledge is important if you want to create a calibration table. Otherwise, no problem. Am I correct? Which range bias is more? In which range bias is less? You create a table. Morning, your watch will run 10 minutes faster. Afternoon, your watch will be 15 minutes faster. Evening, your watch will be 20 minutes faster. I am asking you time in the evening. What will you say? You will minus 20 minutes. Now, how your watch is behaving? Your watch is behaving in a linear manner?
No.
Non-linear. So, understanding about the linearity is important if you want to create a calibration table. So, we stop here for our coffee. So, we know about the bias and we also spoke about the stability and linearity part. And now we are going to talk about precision. When I say precision, I am talking about consistency. When I say accuracy, we are talking about the closeness to the true value, right? When I say precision, we are talking about consistency. When consistency comes into picture, whenever you take multiple readings, consistency comes into picture. Hope all of you agree with me, right? When you are asking people to measure repeatedly, they have to be consistent. You're asking them to measure 3 times. They bring 3 different readings. That it is not, consistent. So there is some variation we can see. So in terms of the inconsistency, there are 2 types of inconsistency. One is called repeatability error. The other one is called reproducibility error. When you are employing only one appraiser, if there is an inconsistency in the reading, that is called repeatability error. When you are employing multiple appraiser and they don't agree to each other, the inconsistency is called reproducibility error. All of you understand what is repeatability error and what is reproducibility error?
Yes. Yeah.
If you alone measure a product 10 times and you see a variation, that variation is repeatability error or reproducibility error?
Repeatability error, single person.
Can you see the readings of a single person in the form of a bell curve? You have measured a product 10 times. And what is the center line? Center line is the average of the reading. You have used this average here, isn't it? 25.4051. This is average. This average appears in the center line. Can you see that? Yes. But for the bell curve, you have calculated average. My question is, can you also calculate standard deviation? Can you also calculate standard deviation? Possible or not?
Yeah.
Average, how to calculate, we did not teach, but you all know. You add all the number, divide by the number of numbers, that is average. Similarly, standard deviation also can be calculated. If you are very consistent, the variation will be minimal. If variation is minimal, standard deviation will be small. If you are not consistent, if you are very inconsistent, what will happen to the standard deviation? It will increase. Am I correct?
Correct.
So by looking at the standard deviation, you can guess about the consistency. If the standard deviation is very less, readings can be more consistent. If the standard deviation is very high, readings can be less consistent. If the readings are less consistent, the error committed is called repeatability error. But I am interested in quantifying the repeatability error. I am interested in quantifying the repeatability error. You remember, we spoke about normal distribution, to some extent. The bell curve, you all remember, right? The center will be average. What will be the distance of the control limit from the center? Say, for example, let me draw the control limit here. This is your center line. This is center line. Average. I move to the left from the center line. I have come here. Almost, the major percentage of the curve is covered. Am I right? This line is called upper control limit. Sorry, lower control limit. This line is called lower control limit. Any idea what will be the distance of the line?
3 sigma.
Very good. Similarly, I move away by 3 sigma from the center to the right side. I have come to this point now. This line is called upper control limit. So this side is also 3 sigma. When sigma is the measure of repeatability error, sigma carries information about the error. Am I correct? How many sigmas are there within my population?
6 sigmas, I think.
6 sigma. So calculate the sigma in the data provided by the appraiser, multiply it by 6. That will be the maximum possible error that particular measurement system can bring in if allowed to collect the data. How many of you understand?
Come again, please.
If I make such measurement system to collect data in my project, he can get me a error of maximum of 6 sigma. Why? When I did a small study, I realized, there is inconsistency. That inconsistency, I wanted to quantify. So I calculated sigma out of it. I know any population. See, if the population standard, if the samples, this is a sample, please understand. When you conduct a study, that is a sample. That is not project data collection, isn't it? Project data collection will commence after measurement system validation. All of you agree with me?
Yes.
Right now, this is a simulation. I just, asked my team to collect the data. They collected data. With some data, I understood sigma is this much. If sigma is this much, 6 sigma will be this much. If my sample is a representative of population, then the same will be the error I can expect in my project data also.
Sir, one query. How we understand the sigma from the sample?
Okay. So let me write the formula.
Sir, before that, I have a question. Actually, what is 3 sigma and how we measure the 3 sigma?
So sigma is standard deviation.
Yes.
Okay.
And somebody asked, how to calculate standard deviation. Can you see the formula here, all of you?
Yes.
Sigma equal to square root of summation of x minus x bar the whole square by n minus 1. What is x bar here?
Average.
Sample average. Sample average. And what is n?
Number of
samples or number of readings. Then what is x? Individual reading. What is x? Individual reading. So once you have the individual reading, you can calculate sigma, right? Let me share my whiteboard now. Oh, already this is whiteboard, huh? Okay. Let me erase. Okay. So imagine I have some number. The numbers are 2, 3, 4, 2, and then 5. Now I want to find out the standard deviation. What is this numbers? X. Am I right?
Yes.
So what is x bar?
Average of all these numbers.
Tell me, how much is the average? 2, 3, 4, 2, and 5?
3.2.
11 by 16.
5 points.
3.2, sir.
7, 11, 14, 16.
9,
Wait.
sir.
Okay, 16. Let me make it to 15 to keep the calculation simple. I make it 4, right? If this is 4, what happens? 4 plus 2, 6. 6 plus 4, 10. 10 plus 3, 13. 15.
7.5.
3.
Sorry,
3.
3.
X bar is equal to 3.
15 by
mid-value.
X bar equal to 3. Now what I want to calculate is x minus x bar. X minus x bar. So x bar is 3. What is your x? 2. 2 minus 3 is how much?
Minus 1.
3 minus 3?
0.
4 minus 3? 1.
Minus
2 minus 3? Minus 1.
Minus 1.
Minus 3. Can you see plus and minus? You can see plus and minus, isn't it? This is called variation. Wherever 0, there is no variation. Wherever 0, there is no variation. Wherever 0 is not there, that's the quantity of variation. All of you, do you understand?
Yes.
Yes, sir.
Now, I want to know the total variation. Can somebody sum up this total variation?
0.
1,
Total variation is 0, right?
0.
Does it mean there is no variation in your data?
No.
Well, it's 1 to minus 1. Yeah.
So there is variation, but when I total it, my statistics is not helping me here. So in order to make it meaningful, I'm squaring it. Yes, I'm squaring it. Now minus 1 will become plus 1. 0 will become 0. 1 will be plus 1. This will be plus 1. This will be plus 1. Now what is the sum of the squares of the variation? See, this is called square of the deviation.
5.
Squared deviation And what is this 4 called?
5.
Sum of the
4.
sum of the squared deviation. Now, since I have squared it, I am going to divide this squared deviation, which is x minus x bar the whole squared, by a factor n minus 1. How much is your n?
5 minus 1.
5. 5 minus 1 is 4. So my data is, my sum of the squared deviation is 4. I am going to divide it by 4. So what is the answer?
1.
This is called variance. This is called variance, which is given a symbol called sigma square. Sigma square is 1. Now what is required? What is required?
Sigma.
Standard deviation is required.
Standard deviation.
Standard deviation is equal to square root of variance. Formula for variance is sigma square, isn't it? So how much is my sigma square? 1. So standard deviation is also 1. All of you, do you understand the calculations here?
Yes, sir.
Since variance is also 1, standard deviation also 1. Suppose variance is equal to, let us say, 4, then standard deviation will be square root of 4, right?
4.
2.
2. All of you understand the calculation behind standard deviation? Very simple calculation. You all studied in some standard. Some table, you fill up all those things and then you calculate. Clear?
Thank you, sir. Clear.
Yes, sir.
Now, the standard deviation is a measure of variation. Variation is the error. If I look at my curve, there is, in order to cover the entire curve, I know there are 3 sigmas on the right side. I know there are 3 sigmas on the left side.
Sir,
totally how many sigma? Yes.
Why we write 3 sigma here, sir? Why do you write 3 sigma here?
Are you attending class from yesterday, or you have attended last week also?
Last week also.
I told you why it is 3 sigma. You missed it, right? I told you, right? 3 sigma. Always, if you go up to 3 sigma, like 99.73% of the population will be included. Right? Anybody remember the discussion about normal distribution? I spoke. Every single minute we speak here is actually a productive time for all of you. If some of you don't realize, you may miss out. I think the normal distribution is also missed out. See, we spoke about biological data. You remember? Am I right or not? We spoke about biological data.
Yes. Correct.
Any biological data will follow a bell curve. And in a bell curve, if the control limit will always be at a distance of 3 sigma from the center. The purpose of control limit is when I can see what is happening at the control limit, I am missing out only a small fraction. Am I right? If I can see what is happening at the control limit, I am missing out only a small fraction. 99.73% of the events will happen inside control limit only. Am I right or not?
Correct.
Like what is the average height of people in India? We discussed the same thing. Let me repeat.
Yes.
5.5 feet. Am I right? 5.5 feet is the average height. What does it mean? When I go out and meet somebody, yes, all of them will be around a height of 5.5. Am I correct or not?
Yes.
Many people I am seeing every day on the Indian roads, they will be having height about 5.5 feet only. I am excluding the kids here. Right? That is the advantage of average. Another thing, what will be the standard deviation of the height of Indian population? It is difficult to measure the height of each and every individual, but data is definitely available, should be available. Let me say the average, the standard deviation is 0.25 feet. It's only an assumption because you know how to calculate, right? If you have data, you can calculate. Now I'm not going to calculate. What is the standard deviation? 0.25. Now you can make a statement. Majority of the people in India will have a height between 5.5 plus or minus 0.75. Does it make sense? Plus or minus 0.75. Muniruddin, you asked the question, right?
Here.
Yeah. Tell me, Muniruddin, what is 5.5 plus 0.75? 5.5 plus 0.75. Muniruddin, please add it and tell me. Come on, Muniruddin. Yeah, it's an easy calculation. 5.5 plus 0.25. 6.25. Now I want to know all the people who are attending the class. You are from the Indian population only. Am I right?
Yes.
Anybody here who is having a height of more than 6.25 feet? Can you please come on video? We want to see you.
No.
No.
Nobody.
Yes.
Majority of the population. That's what I said. Majority of the population will always appear inside the control limit. We can have one or two. They're possible. They are called outliers. But the chances of such person appearing in your sample is limited to 0.27%. That means there is 99.73% chance is there for your data to appear inside a control limit. What is the definition of control limit? How much we added? 0.75. 0.75 is 3 sigma, am I right?
Yes.
Similarly,
Yes,
let us check on the left side also. What will be the lower control limit? Average minus 3 sigma. 5.5 minus 0.75. That will be how much?
4.75.
4.75.
4.75.
Anybody here, if your height is less than 4.75, is there anybody available? But nothing wrong. Please understand, I'm not discriminating anyone here, no, because of the height. This is only to understand the concept. If you are having less than 4.75, it's not a problem. It is possible because for somebody to have a height of less than 4.75, for that also there is a population, probability, but the probability is less. What is the probability for somebody to have a height of less than 4.75 feet in India? If you go to Japan, the discussion will be different. Average cannot be 5.5. Average will be 4.5. Because our population is now shifted to Japan. Can you understand, all of you? When I keep on changing the population, I can see a shift in my average. Am I correct? And every population will have some variation. The maximum spread can be understood by going up to 3 sigma on the right, 3 sigma on the left. If you have enough money, enough resources, enough time, you can try to understand even beyond control limit also. It is up to you. Why we generally go up to control limit and limit our thinking? Because when I go up to control limit, there itself I understand 99.73% of the population. Clear?
Yes, sir.
This number and the formula is empirical. Empirical means, based on experience, people have realized. You do the exercise, some exercise. I do not know how many of you did the exercise. I suggested you collect all the people's height, calculate the average, calculate the standard deviation, find out the upper control limit, find out the lower control limit, and check what percentage of people are inside control limit and what percentage of people are outside control limit. You will be able to see the proportion working properly. Similarly, the sales data. Any data that you have, your sugar level, your BP level, the diameter, strength, if you have a sample, if you have a data, average, standard deviation, control limit, you will be able to conclude. Hope people now understand why we are going for 6, right? 3 on the right and 3 on the left. Clear?
Yes, sir. Clear.
Clear, sir. Thanks.
Very good. Suppose when I involve multiple data collector, if the variation is happening, that is called reproducibility error. Multiple appraiser, now the variation. Suppose imagine I am collecting data 3 times. You are also collecting data 3 times. Now, how can I compare my data with your data? Because both of us measure from the same product. Both of us used the same product, same measuring equipment, but my readings and your readings are different. This is also an error. This is called reproducibility error. Now I want to quantify the reproducibility error. Now what will I do is, I will calculate my average as well as your average. If the averages are same, we are reproducible. Do you understand? If the averages are same, because ultimately average is what I'm going to use. But if the average itself is different, there we will understand there is a variation. This variation is called reproducibility error. That is what is described in the graph. First operator, second operator, third operator, fourth operator, nth operator. Every operator will have an average. If there are 10 operators, you will have 10 different averages. Can you type all the averages in an Excel sheet? Now, how many average you will have? 10 averages. Will you be able to calculate standard deviation of the 10 averages?
Yes. Yes.
That is a measure of reproducibility error. If you want to get an estimate of the total reproducibility error, your team might bring, if allowed to collect the data, you multiply the sigma by 6. That's all. Clear, everyone? Right? So I will come to that. We'll also do a small exercise. Just wait for it. And now there is repeatability error. There is reproducibility error. There is some calculation behind. You don't have to break your head for everything. Just, trust us and then use the formula or use Minitab. That will give the result. But slowly, you will be able to understand everything. Now there is repeatability error. There is also reproducibility error. When I sum up them together, that is now called precision error. All of you understand what is precision error? Sum of repeatability error and reproducibility error. And now, how much is this precision error in comparison to the working range? Always the working range is the difference between or the distance between upper spec and lower spec. The denominator is tolerance. The numerator is precision error. Precision error is compared against the tolerance. The ratio is called precision tolerance ratio. Why it is called precision tolerance ratio? Numerator is precision error, which is sum of repeatability error and reproducibility error. Denominator is tolerance. This ratio is otherwise known as gauge R&R. This ratio is otherwise known as gauge R&R. This gauge R&R must be less than 10%. This gauge R&R must be less than 10%. Then the measurement system is acceptable. If the gauge R&R is 10 to 30%, conditionally acceptable. If it is more than 30%, never acceptable. All of you understand how to validate a measurement system? If you have a measurement system, if the gauge R&R value is more than 30%, will you proceed with the data collection?
No.
If it is less than 10%, yes. If it is 10 to 30%, conditionally acceptable. What is this conditionally acceptable? You should know where is your process control limit. You should also know where is your specification limit. If you know the answer, then only you should use this. Otherwise, use only two conditions. Less than 10% acceptable, more than 30% unacceptable. Don't use this in between. If you are using the in between without knowing position of control limit and specification limit, you will not know how much error will be there in your data. So this is what we learned so far. If the specification limits are known to you, denominator will be USL minus LSL. If specification limits you have no idea, then whatever is the variation that is in your data, the maximum value and minimum value, you can use those values as the limits. In that case, that will be called steady variation. Now, please tell me, is that all the statement written here or understood by you? Please read and confirm me.
So study variation, just you mentioned. Can you
Study variation means, see, denominator is tolerance. If the upper spec and lower spec are known to you, the difference between upper spec and lower spec is the tolerance. Suppose a spec, you don't have any idea about specification. You only have data. In that case, the variation within the data, your data will have a maximum value. Yes or no?
Yes, yes.
That is the upper spec. Your data will have a lower minimum value.
Lower specs.
That is the lower spec, right? We are only assuming. That is called steady variation. When will we do that exercise? When specification limits are unknown. Otherwise, use the specification. Because Minitab will work in that fashion only. That's why, the steady variation you need to understand. Okay, any other question? Everyone is comfortable so far today?
Yeah.
Yes, sir.
Right?
Yes, sir.
So now, we will do a small exercise. I'm going to make all of you collect data. And this exercise, I'm going to play some, video clips. So I'm not going to record this. So I suggest the entire range of your process output, reading. The tolerance, customer has given upper spec and lower spec. You select 10 parts in a way that you cover up the entire range. The parts you choose from the center are the good ones. The parts you choose nearest to the specification are the bad ones. Am I right? You should, third important rule, you should have an idea about the percentage of good and percentage of bad. Because you have decided, isn't it, the sample? As a project leader, as a person who is conducting the gauge study, you should know what percentage of the good parts are and what percentage of the bad parts are mixed together. You can keep it 50-50. You can keep it 60-40. It is up to you. Do you understand the point? First point, what I said, the appraiser should not know the true values. Second point, they should not even know that some of the parts they are measuring repeatedly. Otherwise, there is no need to measure. Please understand. And third reason, 10 parts. Fourth guideline,
you should cover the entire range.
Cover the entire range with a 50-50 ratio. 50% of the parts are closer to the target value and 50% of them closer to the specification. So they are now you can boldly say 50% are good and 50 are bad.
Once again, 50-50, sir?
50-50, yeah, 50-50. General practice is 50-50. So with all these guidelines, you can now proceed.
Here, Mukil alone is done.
Yeah. Mukil alone? Yes, you want to comment about Mukil? Yes.
No. If you see Mukil, it's only the minimal variation.
Oh, Mukil is very
good abrasive.
Consistent in terms of the
60.04,
readings. Right?
60.03.
Yes, he is very close. Yes.
But in the four column, he is the highest, 25. As compared to others.
We can figure out all these conclusions by conducting the MSA study, right? And we'll see. Yeah, crossing that slide is difficult. Okay. Now, so you see here, there is a sigma for repeatability. I spoke about it. There is a sigma for reproducibility. If I combine, that will be the overall sigma. That will be the overall sigma. Always when you are combining the sigma, this is the procedure. You should square and then you should add and then you take the square root. That is the overall sigma. This overall sigma, when you multiply by 6, you get the overall error. What is overall error? Repeatability error and reproducibility. Both are together now. This overall error is known as precision error. You see the numerator, 6 times sigma of the error. Denominator, upper spec minus lower spec. Tolerance. Numerator is precision, denominator is tolerance. And the ratio is called precision tolerance ratio. The other name for precision tolerance ratio is gauge R&R. It should be less than 10%. More than 30%, unacceptable. Now, in order to understand the in-between condition, I am creating a scenario. The requirement is 100 plus or minus 0.5. What is 100? Target. What is upper spec? 100.5.
100.
You can see here. What is lower spec? 99.5. Now I am bringing few more things. Now imagine your gauge R&R is 10%. That means 10% of your decisions can go wrong. Am I right? You want to produce throughout within this range. But let us assume our gauge R&R is 10%. That means 10% of the products, you may take wrong decision with respect to 10% of the products. Now, 10%, this region is called specification zone. Any value between 99.5 and 100.5 is called specification zone. Now, the brown color area, you can see this area, isn't it? The brown color area is nothing but 10% of the specification zone. All of you understand the meaning of this arrow?
10%.
Same 10% here also marked. Same 10% marked outside also. Same 10% marks outside also. The brown color region are called uncertainty zone. If you take a decision using your measurement system in this area, your decision can go wrong. I'll tell you why. But but this zone is called conformance zone. Why it is called conformance zone? Even if there is a measurement error of 10%, a good product will be concluded as good product only.
So still in the specification limit, yeah.
Yes. Imagine there is a measurement coming here. You have 10% error. So what will happen? The reading will appear here. Am I right? Then also the product is within the spec. A good product is getting classified as good product only in the zone of conformance. That is why the zone is called conformance zone. Suppose if you produce here.
Uncertainty.
Uncertainty. Let's say, what will be this value? The brown color area value? 10% of the specification zone. Specification zone is 1 mm. Am I right? 10% of 1 mm is 0.1. That is why 0.1 is written here. Now imagine the product characteristics is 100.45. 100.45 means product is acceptable or rejectable?
Acceptable only.
Acceptable. But your measurement system has got an error of 0.1, 10%. Now 100.45 can be recorded as 100.55. Tell me what will you do if your quality inspector record 100.45 as 100.55? Tell me, what will you do? If 100.45 is recorded as 100.55, will you accept the product or reject it?
No, reject the product.
But what is the reality? Your product is good actually. A good product is getting rejected because of the measurement error. This is called type 1 error. This is called type 1 error. A good product is accepted. This should not happen in your factory. That is why you are putting a condition. Type 1 error should be less than 10%. All of you understand why we say measurement error should be less than 10%? You can't say, error is unaccepted, but 10% is tolerable. Similarly, a bad product sometimes will be considered as a good product. That is also possible. Imagine you are produced here 100.55. Your people will mark it as 100.45. Possible or not? Plus or minus? Possible.
Possible.
So if you reject a good product, that is type 1 error, the manufacturer's risk. Good product is rejected. But if a bad product is accepted as good, now consumer is under risk. That's called a type 2 error.
External risk.
Yeah, type 2 error. There are two errors, type 1 error and type 2 error. Type 1 is manufacturer's risk. Type 2 is consumer's risk. That is why we wanted to limit to 10%. Now, imagine you have a process which can produce outputs in this fashion. Can you see output everywhere throughout the tolerance? Is it a good practice? Is it a good practice?
Yes.
Good practice.
What?
Looks good, right? Looks good.
Looks good because within the limits actually.
The specification zone.
Okay. Imagine you are producing like this. Now, what percentage of your products are under risk of getting the type 1 error and type 2 error? What percentage of your products are under risk?
10.
Type 1%.
10% on the right side?
10% right side, 10% left side.
10% on the left side, right? And you understand the risk. So in my opinion, you should not produce in this manner.
Yeah.
You can produce like this.
Oh.
Now, none of your products are under the risk of, type 1 error or type 2 error. Nothing will happen. Always your decision will hold good. Do you understand? Even if the gauge R&R is 20%, then also your decision will not go wrong. Why you are able to now admit even 20% error? You are seeing your control limit well inside the specification limit. Am I correct?
Within the specification limit.
Well inside the specification limit.
Well inside.
Even if the gauge R&R is 30%, yes, still you can use the measurement system and continue. Your measurement error cannot become, the reason for wrong decision. No. A good product is always classified as a good one. The bad product is always classified as a bad one. Simply because I am having a process which is, really capable. I can see the control limit inside the specification limit. Only under such situation, you can use the second condition. All of you understand when to use the second condition?
Yes.
Otherwise, use only the first and third condition. That's all. Less than 10% acceptable. Otherwise, unacceptable. So this is the Minitab report for a gauge R&R study. You can see the gauge R&R value, total gauge R&R value 27.37. What is your conclusion now? What is your conclusion if you see gauge R&R of 27.37? Acceptable, unacceptable,
Under condition.
conditionally acceptable.
Conditionally acceptable.
Conditional acceptance.
And now the 27.37 repeatability is 20.38, reproducibility is 18, which that means repeatability is dominating than reproducibility. If repeatability is the issue, who is bringing that? Whether it is Santosh or it is Sandeep or is it Mugil or is it Muniru, then I can find out. In order to find out, with the help of the same data, I will plot certain graphs. I'll plot certain graphs. Now, 6 graphs, all of you can see in my slide. The first graph is a bar chart. You can see here. The second graph is a control chart, R chart. R chart means range chart. The range chart can help you to understand the repeatability of the operation. And the X bar chart can help you to understand whether your measurement system is capable of discriminating the good and bad. You mixed the good and bad, isn't it? You mixed up some good items, you also with the bad items. So whether if your measurement system is discriminating the good and bad properly, you will see the bad parts appearing outside the control limit. You know the percentage, you only mixed it up, 50%. 50% of the points should appear outside the control limit. If this is not happening, your measurement system is not good at discrimination. It should differentiate good and bad. That if that is not happening, your measurement system is bad. Now here, you used 10 parts. Every part is measured 3 times by 3 appraisers. So from every part, 3 appraisers, each 3. Totally how many readings? 9 readings. Can you see the 9 readings? Now look at the 10th part. Look at the way your measurement system measured the 10th part. Can you see too much spread while measuring the 10th part? While measuring the 10th part, your measurement system is really struggling, bringing more error. Can you see that, all of you?
Yes.
But same measurement system is really good while measuring the 6th part and 7th part. So you can train your team on how to measure, product of type 10. You give them a training how to do it, because I could see more error coming from that particular item. Maybe operational definition or something, whatever. You make necessary changes. And now look at the box plot. This is called box plot, blue color box. The center line, horizontal line, that is called median. The circle, this is called average. What is expected is all the 3 average should lie on a horizontal line. Is it happening here?
No.
What is that you are noticing here? The average of the second operator is pulled downward. Can you see that? Yes or no?
Yes.
If all the 3 average appear on a flat horizontal line, then reproducibility is better. Now, who is the reason for poor reproducibility here?
Operator
2. Operator 2 is measuring slightly, differently. But 1 and 3, they are measuring in a particular manner, but 2 is differing from them. I want all of them to work in the same manner. All can be correct, all can be wrong. That's not a matter. But all should follow the same procedure. That's very important. That is not happening here. 2 can be advised or 1 and 3 can be advised. I do not know which is the right. That also you can understand. All that depends on your choice of the 10 components. Please understand. You have to deep dive into the subject so that you can understand all the graphs. Graphs can throw useful information, right? And now look at the R chart. Let us talk about repeatability. What is R? Can you tell me what is R? R means?
Range.
What is the formula for range? Maximum
To minimum.
minus minimum. Operator 1, part number 1, he measured 3 times. There will be a maximum, there will be a minimum within the 3. The difference between the maximum and minimum is the range. If he is very consistent, the range will be very less. If he is less consistent, the range will be very high. Am I right? He maintained lower range for some products, but for part number 4 and 5, can you see the range is becoming very high? Can you see the variation is very high when operator 1 is measuring part number 4 and 5? Can you see that, all of you? Yes or no?
Yes, sir.
Yes.
Yes, sir.
He requires some training on how to measure products of type 4 and 5.
Sir, one clarification. See, with this chart, how can we identify whether this is from operator 1, 2, or 3?
Yeah, here it is written, first part of the graph is from operator 1. This is from operator 2. This is for operator 3.
Got it, sir.
Operator 1 measured all 10 parts, each 3 times. There are 30 readings which came exclusively from operator 1. Use those 30 readings and plot it here. With the help of the 30 readings, you have got 10 ranges. Every range is collected from 3 data points of each part. You understand? Each part is measured 3 times. First part, first range. Second part, second range. It is going like that. Now looking at the range chart, tell me who is more repeatable? 1, 2 or 3?
3 is more repeatable. Sorry, 2 is more repeatable.
Okay. So 2 is more. 2 is better. And who is next better?
3.
So all of them are okay only because I could see all the points well within the control limit only. Right? When I plot a range chart, I don't see any point going beyond the control limit. All are okay only, but within the 3, one is contributing to the repeatability error to a larger extent. Can you see that, all of you?
Yes.
And 2 seems to be too good because all of you are saying, but I have a doubt with 2.
3 is consistent, sir. 3
is consistent, but now I want to talk about 2. I see a problem with 2. Can anybody understand what is that problem I could see with 2?
So again and again, he is getting the same point.
Yeah. I could see the graph going like a horizontal line.
Correct.
Which is quite unusual. Am I right?
Right.
Imagine an ECG graph going up and down. That's usual. Imagine the ECG graph going like a flat horizontal line. Unusual. Isn't it? There is no life. So though his readings are better, it is much, much better. That is creating doubt for me. Right? So this kind of conclusions can also be drawn if you understand everything about the normal distribution. So this is how you can improve your measurement system. And now let us see how we can use Minitab and create similar graph ourselves. Can we see that now in just 2-3 minutes?
Yes,
Though
sir.
there is a lot of theory behind, if you know how to use Minitab, or if you learn how to use Excel to do all these things, and RK sir can give a template for each and everything. Even for gauge R&R also, he has developed a template. You can benefit from it. But then, you need to understand the tool and then you can use the template. You don't have to break your head, to do the calculation and other things that we have already taken care. So now I'm sharing my Minitab screen. Please confirm if you can see my screen. All of
Yes,
you
sir.
can see my screen? Yes.
Yes, sir.
And now you should go to Stat. Please go to Quality Tools. Come to Gauge Study. After coming to Gauge Study, there is an option to create a worksheet. Create a worksheet. Now, number of parts, I said 10 minimum required. Number of operators, 3. Let me put your name here. We have Santosh Gori and we have Sandeep. And who is that? One more. We have, okay, Mugil. I'll take Mugil. So 3 people, 3 operators, 10 parts, and each part how many times? Let us say each point 3 times. Each part 3 times. 10 into 3 into 3, how much?
90.
90 readings are required to gauge on your measurement system. 90 readings are required to conclude about your measurement system's capability. Please note, still we have not collected data for the project. We are only testing your measurement system. If testing going well, the measurement system is acceptable, I'll give a request or signal to collect the data. My team will start collecting the data. My data can be credible. So now I am giving okay.
Sir, I have one question here.
Okay, yes, Ram.
Sir, so when we are collecting the data, its volume is mandatory because we are taking the sample range is 90 actually for 3 people for each 10. So if my volume is more so volume is mandatory here.
Yeah, see, 10 of 10, I justified you why 10 parts, isn't it? You should be able to cover the range.
Yeah. Okay.
See, what you are doing is, a study.
Okay.
If the study is not going to represent the real time scenario, but study can, lead you in the wrong direction. Always your sample should be able to represent the population. What is population here? The real data your team will be collecting. I want my data to be, credible enough. For that, even the 90 itself may or may not be sufficient, right? So you have to make a judgment. All right. So now look here. The gauge R&R worksheet Minitab has created. All of you can see run order, parts, and operator. So you can see 90 rows. Can you see all of you 90 rows?
Yes, sir.
Now, in this column, you can write your measurement. If I have created the worksheet in this manner, and then, conducted the gauge order study live with the songs I played, but that will be a tedious job. That's why I have not typed in the, the Minitab. I just, comfortably typed in the PPT. If I have typed it here, we can conduct a gauge order study live here. I am ready to share, and moreover, we did only, 4 songs. We played only 4 songs. So with those limitations, if you can manage to type the readings here, Minitab will throw report on all of you. I mean, your measurement system. Now, I have an inbuilt file. Let me open that file. Open the worksheet. Now, sample data folder. You click this. Here, gauge. Gauge AIAG. Gauge AIAG. Now you open. Can you see some data here? Part number, operator name, measurement. Can you see, all of you, how many readings are here? Again, here there are 90 readings.
90, yes.
That means 10 parts, 3 operators, 3 times each. Now I want to analyze. I want to know how much is the gauge R&R. Let me go do the analysis. Stat. Quality tools. Where should I go now?
Quality tools.
Gauge study.
And create
Gauge study. And after that, now there are options. Now I will go for the gauge R&R study crossed. Why it is crossed? Whatever part operator 1 has measured, same part is measured by operator 2 also. So the study is called crossed. So click that. Now part number, which column contains part number?
C1.
Click and select. Operator detail, C2. And measurement detail, I mean the data, C3. Click and select. You can analyze using X bar R method. That is what I have shown, X bar R method. Gauge information, the gauge name. Let us say we used stopwatch, that's the gauge name. And date of study, 16 April. And then reported by the green belt and black belts. And gauge tolerance, if at all there is any gauge tolerance, you can mention that some value. And all these things will appear, in your report, and in real time it will make sense. But now it is, just to let you know. And now go to options. Can you see the number 6?
Yes.
I also used the number 6, isn't it? During explanation. That same number, the meaning is here. Now, now do you know upper spec and lower spec? As far as this data, what is the data? We don't know, right? So if let us assume some value, upper spec and lower spec. What is the upper spec and what is the lower spec? Or what is the difference between the two? Let me say the difference between the two is 6 units. When tolerance is known, the denominator will be USL minus LSL. When tolerance is unknown, Minitab itself will use the data and give you the percentage of error with respect to the study variation. Now I have given. Now when I give OK, all job will be done for you. Let me see. I'm giving OK. One more time. OK. Can you all see the graph coming on?
Yes. Yes.
Yes. Yes.
Now let us look at the report. Yes. Report means it comes here. Gauge R&R study X bar R method. There is first, can you see all the details? No, gauge details, whatever I typed, that is very here. And now there is first table which you can skip. First table you can skip. Because the first table is constructed using variance. But the second table is constructed using standard deviation. Our discussion is based on standard deviation. So we must look at the second table only. All right. And now tell me, how much is the gauge R&R? How much is the gauge R&R?
30.5.
And also read the column name. Variation divided by tolerance. Since tolerance is given, use the last column. If tolerance is not given, you will be using this. But right now, tolerance is known. 30.58. Is this measurement system acceptable?
No, not acceptable.
Not
Greater
acceptable.
than 30. Greater than 30.
Measurement system is?
Not acceptable.
The measurement system is unacceptable. Which is the problem? Repeatability or reproducibility. And you get some estimate, right? Reproducibility is dominating. And now I want to see the graphs. You want to see the graphs means click this button. Graph will appear. Yes, the gauge R&R. Yes. And now read through the graph and try to understand what's exactly happening. And who is problematic. And who is contributing to the repeatability, who is contributing to the reproducibility. Now, who is contributing to the repeatability error? 1 or 2 or 3?
2, sir. Operator B.
2 is contributing to the repeatability error, that is abrupt. Looking at the graph, can you see that, all of you? Particularly, while measuring part number 5, he is bringing more error. You can see that, all of you.
Yeah.
Now, reproducibility. Who is not aligning with the team? A or B or C?
C.
C is not aligning. So this is how you can read the graph and you can take appropriate action. Slowly, the repeatability will go down, reproducibility will go down, and you will be able to get your gauge R&R less than 10%. Understood? All of you?
Sir, in that, what is part-to-part variation, sir?
Oh, part-to-part variation. You know what is part? Part means your product, right? Yes or no? Part means your product.
Yes, sir.
Your product is having a variation. That is the real problem you want to fix. Your part is having variation. That is the real problem you want to fix. First graph. Part to part variation, the source is process. Am I right? Why there is a variation in your part? Process variation. You want to control the process variation.
Yes, sir.
So part to part variation means the variation that you can see between the parts, but you don't want to see, but there is a lot of variation, isn't it? That's the real problem you want to fix. Now there is one more variation. What is one more variation?
Measurement variation.
Measurement. With the measurement variation is too much. Will you be able to see the part to part variation? Part to part variation is the problem. If your windshield is fully not clear, will you be able to see the road?
No.
If measurement error is too much, you can't even understand a variation exists between the parts. But the variation that exists between the parts is the problem you want to fix. All of you understand?
Sir, if you don't mind, could you go to that graph sheet, sir? Sorry, you have shown that value in Minitab. Sorry.
Okay.
Say 20 to.
Yes, I'll show it. This one? This one, correct?
Yes. Sir, no, sir. The value 20, repeatability 20 and reproducibility 28.
So you want to see the data, va?
No, data output from summarization from this one.
Yes, sir, the end result.
Minitab.
Yes. Wait. Session window. I should go to session window. Here. You are saying this.
Yes, sir. Sir, in this, my understanding is you're telling that part to part is 110 and remaining repeatability and reproducibility is 20 and 22. How can I want to account, sir? Say, for example, out of 100, 20, 22, I'm getting a little bit confused here.
Yeah. You should get confused because we are working with standard deviation.
Okay.
We are working with standard deviation, right? There is one more table here, which is called variance. Here you can see the number tallying properly. Can you see the number tallying properly?
Yes, sir. Got it. Okay.
You won't see proper tallying when you are working with standard deviation. Because to calculate the standard deviation, we square the value, isn't it? If we sum up everything, that will be more than 100%. Can you see that? Because you squared, it is not the actual numbers. You squared, so you can't, get the numbers tallying to 100%. If you expect tallying, you should learn the rules with respect to the variance. With respect to variance, right? But we discussed only with respect to gauge R&R, which is a common practice. So you don't expect the tallying here, but you know which is bigger, which is smaller. Clear?
Okay, sir. Got it. Sir, suppose if I'm having issue is on my measurement error means my value will show in the variance column. Say, for example, part to part is minimal and repeatability and reproducibility will be maximum, right?
See, part to part is the problem we want to attack. Part to part is the problem we want to attack. That is our project. In order to do the project, we use a measurement system, and measurement system itself is having this much problem.
Yeah.
A problematic fellow cannot help another problematic fellow, isn't it? You himself have a problem and you are trying to solve others' problem. That is not possible. You have to feed yourself first. So the measurement system itself is having a problem. Don't use that measurement system to get your problem solved. That is the point. Clear?
So we are just identifying that the input is garbage or not.
Yes, exactly. If the gauge R&R value is less than 10%, yes, the data is worth for analysis, right? So see here, the first graph alone I wanted to insist because Ashok has asked about it, right? So part to part variation is represented here. There are three colors shown here. If you type the tolerance, upper spec and lower spec, you should use the yellow. If you don't type the tolerance, you should use the red. And the blue is for the first table. You remember I have shown first table, variance. So we don't want to use the first table. and we know the tolerance. That means we should look at only yellow color. So I remove the remaining two. This is the condition right now. The problem is seen as a taller bar, and the problem within your measurement system is seen as a smaller bar. That means this is this is almost close to 32% of the total problem. Right? Now the question is, can I use this to fix this problem?
No.
Yeah, because it is more than 30%.
30%.
And now why this problem? Because of repeatability, because of reproducibility. And within the two, which is higher? Repeatability is higher. So I'll take steps to bring down the repeatability. And then I will also take steps to bring down the reproducibility. As a result, this will go down. My measurement system will become usable. So repeatability means, what is the exact source? The exact source is 1 or 2 or 3. I can see here. Isn't it? I can see here. Suppose if it is reproducibility, I can go to the box plot. And now who is bringing the reproducibility? 2 probably. I'll take action in this manner to make my measurement system worthy for data collection. If that improvement is possible, I'll do that improvement. If that is not possible, I will change the measurement system. If I can't do anything, probably I will not proceed with the data collection, because we have the.
So here in this case, repeatability is a higher contributor. So in this case, I have to change the sample, which is part first.
No. Don't. See, changing the sample is not going to serve the purpose. Please understand. Sample is any random selection of 10 parts within your specification. If repeatability is found to be the problem, try to understand what is the source of the repeatability error. Is it, let us say it is operator 2. Now try to understand what went wrong with operator 2. Has he not understood the instruction? Right? You just have to sit with him, maybe arrange a training program for him and check what exactly he did. Maybe if you interact with him, you come to know. Maybe he is not comfortable with the measurement system that is given. Right? So if you just equip him a little more better, then he'll become usable in your project.
Gives us consistent point.
Though I say operator 2, the problem can be any element of the measurement system. It's not necessarily the same person. The person himself can measure wrongly. The instrument that is provided to him can have a problem. The instruction that you have given to him can have a problem. Isn't it? So you need to check in all aspects so that the repeatability bar can go down.
Yes.
Hope all of you understand.
Yes, sir.
Thanks.
So now we are moving on to another topic. What is the topic?
Capability analysis.
Capability analysis.
CpCpk.
CpCpk. Yes, that's what the topic now. Oh God. Give me a minute. I did some mistake. So CpCpk. And those of you who are using the CpCpk in your workplace, you might be familiar. So they are called process capability indices. What are they called? Process capability indices. And the industry expectation or the industry standard is CpCpk should be more than 1.67. How much it should be? More than 1.67. If the process is critical. Suppose if the process is not critical, let's say it is less critical. In that case, CpCpk are expected to be at least 1.33. At least 1.33. So for critical process, 1.33, and for non-critical process, it is 1.67. So
up to 2 can go, I think.
Yeah, up to 2. If it becomes 2, your process capability is 6 sigma.
Yes.
There is a relationship between CpCpk and your sigma level. I think now all of you can see my screen again. right? And now let me open a file, open worksheet, sample data,
इसमें से 2 क्वेश्चन रहता है
sample data, cable.
क्रिटिकल और जनरल में से 2 क्वेश्चन रहता है, वो याद ही कर लेना। क्रिटिकल में 1.33% रहता है और जनरल में से 1.67% रहता है।
Sanjeev, you are talking to me or you are talking?
33%.
Okay, we are talking about CP and CPK, right? And now you can always classify a process into critical and less critical or not critical. If the process is classified or considered as critical, then your CPK must be more than 1.67. Always, please note, always your CP will be more than CPK. In no situation your CP can appear below CPK, right? So what is this difference? Why there are two metric? Why we are confusing with two metric? For calculation of CP, we make use of only standard deviation. What do we make use? Only standard deviation. But what is our understanding about quality? Quality is a function of standard deviation. I wrote already, right? Variability. What is the other one? Central tendency. That means in order to understand the capability of your process, you should not only look at variability, you should also look at the central tendency. Now I have added X bar. The formula for CP uses only variability, but the formula for CPK will use standard deviation and the X bar. So which can give you a better picture of the quality or the capability?
CPK.
CPK is a better measure of capability. Reason, what is the reason? CPK makes use of central tendency as well as variation. Why CP is sometimes misleading? It is not giving the real capability because in the formula it uses only standard deviation. That is why CP is called a potential process capability ratio, not the actual capability ratio. Please note, potential. But CPK is the actual process. Actual process capability ratio. All of you understand the difference, CP and CPK?
Yeah, got it, sir.
In order to calculate CP or CPK or both, you need upper spec, lower spec. You can't calculate CpCpk without upper spec and lower spec. Am I correct?
Yes.
Also, you need information from the process. What kind of information you require from the process? Standard deviation, standard deviation and X bar. If these are available, you can calculate CpCpk. Now, what is the formula for CP? Anybody, can you tell me? Upper spec minus lower spec. That is the numerator. Upper spec minus lower spec divided by 6 times standard deviation.
Yeah.
When I say upper spec minus lower spec, I am talking about customer tolerance. Am I right? The distance between upper spec and lower spec, that is called customer tolerance. Or you can use a better word. What is that? Specification width. All of you, do you understand what I'm writing here? Can I call it specification width? The distance between upper spec and lower spec. The width is specification width. Your process will also have a width.
Otherwise, product spec.
Your process will have a width. From the center, your process will go up to upper control limit. Am I right? You remember our bell curve?
Yes.
What is the distance of upper control limit from the center? 3 sigma.
3 sigma.
Similarly, lower control limit also 3 sigma. So what is the width of the process? 6 times standard deviation. So specification width and process width we are comparing. Specification width and process width we are comparing. If they are same, your CP will be 1. Your process just made it. Your process just made it, just capable. So let us understand this with an example, right? So diameter is the data here. So how many samples you have? You see here, you have about 100 sample. Let me just understand the background of this. Capability analysis, normal.
मिनी टैब नहीं रहेगा ना, वो लेना पड़ता है मिनी टैब.
Upper spec, lower spec 0.5, upper spec 0.6. Please remember, one of you, lower spec is 0.5, upper spec is 0.6. These values are required for us. Now I am going here. Yes. So what is the upper spec?
0.6.
0.6, lower spec 0.5.
And lower spec 0.5. And now you have collected 100 samples. 100 samples, please note, 5 at a time. At a time, how many samples you are taking?
5.
5. That means every time you are collecting a group of 5 samples. So your subgroup size is equal to 5. All of you understand why subgroup size is 5?
Yeah.
Now totally 100 samples you have. That means totally how many subgroups you collected?
20.
Oh, very good. I'll type here. What happened? Yeah. Subgroup size is 5 and number of subgroups. You said 20.
Can you go for mute, Sanjeev?
Yes, see, all of you please pay attention, and otherwise you can't understand the subject, right? So number of subgroups is 20, subgroup size is 5, upper spec is known 0.6, lower spec is known 0.5, process average is required. What is process average? X bar. Process standard deviation is required, isn't it? What is process standard deviation? Your sigma. Tell me where from I can calculate sigma and X bar. Can I use this data in hand?
Yes.
All of you?
Yes.
I can use this data in hand. Now, if you have Minitab will do the calculation for you. Now you go to stat, go to quality tools, come to capability analysis. Then you come to normal. Your data should be normal. Yes. We'll check that normality also. Right now it is normal. And now I come here, single column. Where is the column?
Yeah.
You have the data, column number 1. What is it about? It is about diameter, selected. Now subgroup size is how much? 5. What is the lower spec?
0.5.
0.5.
Upper spec? 0.6. That means what is the target?
0.4, 5.5.
0.55.
Yeah.
0.55 is the target, right? And
That's
now going to option, I think we don't have to give anything in the option. Now you give OK. Can I see a report here, a graph, all of you?
Yes.
Yes.
Let us read here. How much is your CP?
0.9.
0.9 and CPK is 0.83.
0.83.
For a less critical process, for a non-critical process, we need 1.33 minimum. Is it happening here?
No.
Over and above, diameter is a critical characteristics. So how much is required for me? 1.67.
1.6.
But unfortunately, my process, is not even half capable. It is just 0.83. No, say CPK is 0.83. So definitely process improvement is required. Now, which is the problem? Center is the problem or variation is the problem, right? We need to understand. So look at the CP as well as CPK. CP is 0.9, CPK is 0.3. Are they close to each other? Are they close to each other?
CPL or CPK.
More or less close, 0.9 and 0.83, more or less close. If they are more or less close, center has not shifted much. Please understand. If they are more or less close, center has not shifted much. But there is some shift. Process is expected to be at the center, but then, your process has slightly shifted, number one. So, and another thing, but variation is really a big problem. That is the reason why, your CP is also under trouble. If CP is under trouble, it is purely because of variation. If CpK is under trouble, it can be due to the center, it can be due to the variation. You should check. But you can understand whether the shift is too much or not by looking at the distance, by looking at the difference between CP and CpK.
Can you repeat again, sir? The CP, if variation is more, CP is the problem, right?
Yeah, if CP is less, that means variation is more.
Okay.
You can see the control limit going beyond the specification limit. Here control limit is not shown, but actually you can see the curve going beyond specification. Can you see that?
Yeah.
The portion of the curve going beyond the specification will be rejected by your customer.
Exactly. Yeah.
Right? So now let us see the rejection detail also. Yeah.
Sir, here if CP is equal to 1, then process is capable.
Process CP equal to 1 means process is capable, but industry requirement is 1.33.
Okay.
If I go for instead of 6 sigma, shall I go for 4 sigma? Because where I'm sitting in my company is a 4 sigma level. So in this case,
No.
Just clarification.
No. See here, where did you see 6 sigma here?
Sir, standard deviation I'm telling actually.
Standard deviation sigma only you should use.
Okay, got it.
Yeah.
Okay.
Sir, one query. Sir, CpK should be 1.33, right? But in case of CP here, if it is 1.
See, I already told you, CP cannot be less than CpK.
Okay,
If you
CP
take care
should
of CpK, CP will be automatically taken care.
Got it. Clear, sir. Clear.
Very good. So now come down here, look at this table. Now there are rejection happening. We can understand from the graph on the right side also and the left side also. Now the ppm, parts per million. How many parts are can be rejected? Your ppm can be around 10,969. 10,000 ppm could be the rejection you can expect from this process based on the study you conducted. All of you, can you see that? Parts per million can be 10,969. What is 10,969 ppm? Rejected, defective items. I want to reduce the rejection. What should I do? I will improve the process. If I improve the process, what will happen to the variation? Will reduce.
Yes, it will go inside of
As the variation reduces, the curve will move inwards. The curve will start going inside the specification. The entire curve you will be able to see inside. That means your control limit will move inwards. As the control limit move inwards, you can see an improvement, immediate improvement in CP. You can see an immediate improvement because CP completely depends on sigma. As the control limit is going inside, how can a control limit go inside? Only when sigma is going down, isn't it? When sigma is going down, control limit will go inside. Now, once the control limit is well inside the specification, still you see your process, center shifted to the right or shifted to the left. You can correct that also. If you correct the center also properly, CpK will become equal to CP. Ultimately, you should aim for a CpK value of more than 1.67. Ultimately, CpK should be equal to Cp. That is the ideal situation or a better situation. All of you understand?
Got it.
Now let me change this Minitab mode to slide and then we will go for the lunch. And now that you got some idea, but
Sir,
There
Sir,
should
excuse
be.
me, sir.
Yes.
Sir, in
There,
that
yes.
Minitab readings, you shown expected within and overall. No? Expected within means the data points will fall within the control limit, right, sir?
Understand. Very good. Very good. So good, Ram Prasad asked the question, right?
No.
Who asked the question?
Ashok, sir.
Yes, Ashok. Okay. I'll talk about it, Ashok. Just wait for it. See here, CP and CPK. All of you, can you see the formula? CP, USL minus LSL by 6 sigma. CPK, look at the formula. There are X bar also coming. You can see here, X bar also coming, sigma also coming. There are two things. One is called CP upper, other one is called CP lower. Whichever is minimum, that will be picked up as the CPK. This is the formula, right? And now, look at this situation. How much is the upper spec? 50.
Yeah.
Lower spec? 30. Your process has got an average of 40. Your process has got an average of 40. Your process has got a standard deviation of 2. Now upper control limit is 46. How do I know? Center plus 3 sigma, isn't it? Lower control limit is 34. Can you see your control limit inside the specification limit?
Yes.
Yes. Your process is capable. Look at the specification width, very wider. Look at the process width, smaller compared to the specification, which is good. Now the ratio, specification width divided by process width, 20 by 12. How much is 20 by 12? 1.67. Requirement is met. But if my, yes, the same situation only, the same thing only is not shown here. Here also it is 1.67. Now the situation is changed. What happened now? Earlier it is like this. Process is shifted to the right. But now also specification width is 20. Process width is 12. Now CPK still remains 1.67. Does it mean my process is capable now also?
Yes.
Yes.
How yes? Can you see your curve going beyond this? Your curve has gone beyond the specification. Rejections are happening.
Yes.
Still calling your process capable. No, you're wrong. So CP can only be considered as a potential measure of capability, not the real capability. Please understand.
Okay.
That is why CPK is required. If the process is shifted, CP cannot capture it because the formula has got a limitation. What is the limitation? X bar is not included in the formula. Always quality is a function of central tendency and variability. The central tendency is not included. So don't look at CP alone. Better look at CPK straight away. My simple suggestion. You look at CPK. CP will be automatically taken care. But the purpose of CP also I will tell you. And so now, see, CPK is not something confusing. We are earlier, we considered specification width as a whole, process width as a whole. You divide the specification width into two parts. Also divide the process width into two parts. Can you see that here?
Yes.
Specification width is divided into two parts, equivalent parts. Process width also divided into two parts. Totally 6 sigma. So half will be 3 sigma on the right, 3 sigma on the left. Now the blue color bar length can be calculated by finding out the difference between USL and the process center X bar. Can you see USL minus X bar?
Yeah.
Half of the specification width, which is USL minus X bar divided by 3 sigma. This ratio is CP upper. Can you see the formula here? Similarly, the green color bar divided by 3 sigma. That ratio is CP lower. If the process is centered properly, both ratio will be equal. Am I right?
Yeah.
In that case, no confusion. CP will be equal to CPK. But if the process is shifted, now what happens? The blue color bar, can you see the blue color bar decreasing?
Yes.
Now the risk is more on the right side.
The upper side. Yeah.
Rejection will definitely start happening on the right side. So CP upper should be picked up as the capability measure, not the CP lower. Because right side, the risk has increased.
Yes.
So that is why, we introduced a formula here, minimum of CP upper or lower. Whichever side your process is shifting, your capability will drop that side. So use the minimum of the value. There are two values, 0.8 and 2.5. Which one you should pick up now? 0.8. Now CpK is minimum of Cp upper and Cp lower, 0.8. When CpK is 0.8, your process is not capable.
Yes.
Because our requirement is 1.67. And when at the same, while looking at the CpK, for the same process, when you look at Cp, what will be the value? We already calculated, isn't it? This process.
2.5.
0.67.
0.61, sir. Yes.
Cp was 1.67, but CpK is 0.833. When you have these numbers in your table, what do you conclude? Process is capable or not capable?
Not capable.
Not capable.
Not capable. And what is the source of the problem? Variation is a problem or central tendency is the problem?
Central tendency.
Central tendency.
Because your CpK is different from Cp. That is why you are talking like this. Central tendency is the problem. Am I right?
Yes.
Variation is not a problem in your process. Why am I telling this? Because my Cp is 1.67.
1.67.
If Cp is acceptable, variation is not a problem. You don't have to work on the variation. Try to shift the process. Do you understand?
Yes.
Process has shifted to the right. Now you shift it to the left. Automatically capability will go up. Do you understand, all of you?
Yes.
This is the requirement. Cp must be equal to CpK and CpK must be more than 1.66 or 67. If it is more than 1.67, process can be considered capable as well as consistent, because when CpK itself is more than 1.6, Cp will definitely be more than 1.6. Cp talks about consistency. CpK talks about capability. Clear?
Yes.
One example before lunch. Let me take a simple one. Yes. See here, an electronic manufacturing process. The specification for the current flow is 100 plus or minus 10 milliampere. What is upper spec?
110.
Lower spec is 90.
90.
Upper
90.
spec is 110, lower spec is 90.
90.
Process mean and process standard deviation are 107 and 1.5. Compute the CpCpk. Process mean means X bar. Process deviation means 1.5. Now, formula Cp equal to specification width by process width. Otherwise, USL minus LSL by 6 sigma.
6
You
sigma.
know all the value USL, LSL, 6 sigma. Cp equal to 2.22. Does it mean my process is capable?
Capable.
Yes.
Yes.
You are wrong. That's not the learning you had so far. You have measured only Cp.
Yeah, no, not capable.
Minimum value.
When you see a healthier Cp, you can conclude, your process is consistent.
Yes.
You can say consistent, but your process can be consistently good also, consistently bad also. Right?
Yeah.
And now coming to CpK, minimum of Cp upper and Cp lower. What is the formula for Cp upper? USL minus X bar by 3 sigma.
Yes.
Cp lower, X bar minus LSL by 3 sigma. You know all the value, USL, everything. Substitute here. Cp upper is 0.66. Cp lower is 3.77. Which one you will pick up now? 0.6 or 3.76?
0.6.
Minimum. Yeah.
0.6.
0.66.
Can you tell me which side your process is shifted? Right side or left side?
It is upper side.
So
Upper
right
side.
side. Your process
Yes.
is shifted to the right. Your CpK is 0.66.
6. Process is not possible.
Process is not capable. Definitely
Capable.
rejections will happen. Now, what is the remedy? Do you want to work on variation?
Process.
Process
Not
variation.
required, because variation is very good. You
Quantity.
see, you already have a good Cp. No need to work on variation, but you should work on the process center. So move the process mean closer to the target. That is the remedy. But how will you move? We will discuss in the boardroom. Statistically, solution is offered. All of you understand?
Yes.
This is how you need to decide. Now tell me, for a process, Cp equal to 0.94, CpK equal to 0.33, and clearly process is not capable. What action is needed? Come on, all of you.
Improve the variation.
Process.
Will you work on the? Will you work on the
process?
Change the process. Change the process.
Work on the
Yeah.
process.
Improve the process.
First thing is statistical solution. Second thing is practical solution. Now let me hear the statistical solution. Is your average okay? Is your variation okay?
CP is good.
CP is good, yes.
Are you happy with the CP? What is the industry standard?
No, 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 no.
Sir, or to work with
Both are
both.
in trouble. You can see both are in trouble.
Yes, both are in
CpK is
trouble.
under deep trouble. Right? We need minimum 1.33 for non-critical process, 1.67 for critical process.
Critical process. Yes.
See, why not 1? Why 1.33? Imagine your salary is 1.5 lakhs. Your wife spends all 1.5 lakhs. Will you be happy?
No.
You are capable. Your expense is 1.5 lakhs and your earning is also 1.5 lakhs. What will you try to do now? You will try to control your wife, right? Hey, don't spend
Yes,
this.
yes.
You spend only half of the money I am earning. You want to
Yes.
remain doubly capable. Isn't it? So just capable is not helpful in a real time. Don't settle with a value of 1. Aim for at least 1.33. If possible, at least 1.67 because the process is critical. If you are doubly capable, your process is 6 sigma, that's all. You are earning 1.5 lakh, but your wife is spending only 75,000. You should be happy about your wife in life. Both your wife and life. Isn't it? You are now doubly capable. Even though you spend 75,000, you still save 75,000. Half of the tolerance is consumed. Remaining half of the tolerance will be available as a cushion. Failure is there, isn't it?
Yes.
If you are doubly capable, your process is 6 sigma. If your process is 6 sigma capability, what will be the CpK? Will be 2.
2, more than 1.67. Yes.
If your process is just capable, your CpK will be 1. That is a 3 sigma process.
Yes, still not.
A 3 sigma process, the success rate is 99.73. At that point of time, you will see the control limit overlapping the specification limit. Am I right? And now in this case, Cp equal to 0.94, CpK equal to 0.33. Your process is clearly not capable. First thing, first advice, you should reduce variation because Cp is under trouble. Reduce variation. Another thing you need to do is shift the process towards the target. Move the process mean towards target. So those are the suggestions. Those are only statistical suggestions. But how will you reduce variation? How will you move the process mean? That requires understanding on the process. Hope all of you understood the CpCpk concept. But we will be